Okay, third time lucky. Good morning, everyone. Great. So my name is Hari Kiran. I'll be ranting about Postgres and multi-master, active systems and distributed databases for the next 90 minutes. I'll try to keep it as interesting as possible. And again, there are quite a few of my colleagues. Now, I bumped into a couple of folks who said, hey, we haven't heard about Postgres, but looks like Postgres is doing well. How many of you think that Postgres is doing well, Postgres is good as a database platform? Can I see hands? Exactly, right? That's why we are all here then. Great. So before going into the actual topic, how many of you are using Postgres at this point of time? That only 3 or 4 hands are not up and running. Okay. We'll make sure you guys are up and running after the days PGDay is done and dusted. All right. How many of you have heard about replication technologies in databases? Okay, everybody, that's great. I mean, I don't have to do the, so that I don't have to do the talk. Everybody knows about replication. Kidding. Yes. So, how many of you have heard about logical replication? Not Postgres, nothing to do with any specific database. How many of you have heard about logical replication? That is decent stuff. Great. So, what we are going to be doing is we are going to be talking about active replication. But before going there, we'll set some groundwork and make sure that some of our colleagues who do not know the entire landscape of what all Postgres can do and cannot do. Right? I think I will have one slide which has. Right. Let's look at this slide and get to know what all Postgres can help some of the users that are at the enterprise level, at startups. What we are looking at from a database platform standpoint, right? So, if you look at the Postgres as an AI database, right? Everybody is behind AI nowadays, right? So we are starting off the bat saying, no, hey, I've got this Postgres database engine at the top, right? Everybody know about relational tables, right? These are the tables which have got columns and then rows and stuff, right? Where you store your information. Now, keeping this in place, right? Take a look at the left-hand side. What all you see? Now you are seeing applications, you are seeing users sending across SQL queries and the agents and API layers that are going to be talking to the whole database from a CRUD operation standpoint, doing analytics, doing a lot of read activity, doing a lot of read write activity, so on and so forth, right? Now, we are not going to get into the whole AI piece of it, but what Postgres offers us from a database standpoint is it's a completely open source database, right? So, no restrictions at all, right? You can just pick up the source code of Postgres and redistribute it, right? And you can redistribute as though it is your own database or your own source code, right? You can just massage and do some changes to the sequels, changes to the whole code base, and boom, you have your own database up and running, right? That's the whole magic around the Postgres database that we can see, right? Now, everybody is talking about, hey, does Postgres have the AI capabilities or not? That Postgres is ready for the next generation of data processing and database management. So this is our answer to that question, right? So you will be able to have You will be able to persist your embeddings. You will be able to persist your vector data. You will be able to get TBs of your data just persist in the Postgres ecosystem, and you will be able to do your own queries, processing, AI mapping, whatever it is, right? So you will be able to do a lot of that stuff, right? So that's the whole AI and the Postgres culmination, I would say, right? Does that make sense, folks? Okay, that is the short intro, and now we will go. All right, a bit about myself. Been doing databases. That's the only thing I know. I got married to Postgres before I got married to my wife. I keep cracking this joke, and it's been almost 2 decades, I would say. No, I mean the love story is still going on and on and on, right? I've now founded a company called Open Source TP, and I've been running it since 5 years. Apart from that, I run a lot of community meetups at Hyderabad, Vizag, Chennai, and so on and so forth. And Postgres being an open source ecosystem, right? Everybody has got their own agenda, from running a community, writing Postgres source code, right? Writing extensions that are going to help some of the use cases and so on and so forth, right? And I've also been part of the code of conduct committee with the global Postgres committee. So if you have any issues with respect to the Postgres community per se, please reach out to me. I'll be happy to answer some of the questions or any of the concerns that you may have. All right, so this is the very, very high level agenda of what all we will be talking about today. And like I said, the very short introduction about Postgres that we have had, we will go straight into the replication architecture. We will straight go into the replication technologies that are available, the methodologies that are available in Postgres per se, right? I had seen a lot of hands when we talked about replication. So I'm going to go take a look at some design principles from a replication standpoint. Hi folks, we just started and then we looked at Postgres, and then now we are in the actual topic for today, right? All right, so from a design principles standpoint, right now, what do you think is important from having a replication architecture at a database level, right? If I look at database replication, what do I say? I've got two nodes or two tables on different cluster entities, and they are able to communicate with each other, right? They are able to communicate whatever the data that is available on node 1 is being sent, right? That is replication at a very, very, very basic level, right? Everybody agree? Everybody is good with that, right? Now for us to look at, if we are fast forwarding and saying, hey, I've got an active system, I have got async replication, I've got an asynchronous replication, I've got logical, I've got physical, I've got hybrid, I've got multi-master systems, active replication, right? So now the tables are changing relatively, in a dynamic fashion, right? Now, what do we have at the very design or a basic level, very, very, very basic level, right? What are all some of the algorithms that Postgres has got, right? How do we make sure that consistency, availability, and then I'm quoting the CAP theorem in place. So why, in what way Postgres actually implements them, right? What are all some of the design principles that we have taken into account and built the entire replication architecture here, right? So if you look at the very first thing, right, consensus mechanism, right? Now, can anybody tell me what is a consensus mechanism? Yes, please.
Yeah. So when we have multiple nodes where writing is happening, so before you commit, everyone has to come at a conclusion that my latest, whatever data I am committing is same across all the tables.
Right. Right. So I am sending across some database transactions. My colleague over there has to receive the transaction and then acknowledge the fact that, hey, you have sent me 100K rows, and then this is what I am persisting on my side. This is how I am going to be committing. So there is a whole a gamut of things that happen whenever we are sending across some transactions in the distributed ecosystem, right? So that's the consensus mechanism that we are talking about, right? So how rock solid you can make that consensus mechanism is what there are tons and tons of methodologies that are available, mechanisms that are available, right? A very prudent approach, or an approach which has been there for a while, is the 2PC, which is two-phase commit. So two-phase commit is pretty rock solid. The only caveat, or the only caveat, the con I say, is it is relatively slower, right? Which means that I am sending across my 100,000 records, and then my colleague there is receiving. Yes, he is receiving, but what happens is there is a lot of operational calls that are happening between our databases, right? Between our replication protocols. So that is going to be relatively slower. So we want, I mean, in a world where we are looking at 5 milliseconds latency, 100 milliseconds latency between the availability zones, right? So speed is something that we do not want to compromise on, right? So just to make sure that. And then the next is the raft algorithm. How many of you have heard about raft consensus algorithm? People who have written code for repmgrds or PG autofailoverts would have known this, right? So this is something that is already made available with Postgres physical streaming replica, right? In addition of a couple of tools called as repmgrds, patronis, and so on and so forth. What Raft does is it always makes sure there are 3 cluster entities to start the ecosystem with, right? And then make sure that at any point of time we will have to take a quorum election or a voting process in place. So I will need 3, and then whoever is not available will take a call and say, hey, this is the next cluster entity that is going to take care of my CRUD operations, which is the read write activity in place, right? Paxos also works in the same fashion. Now we are talking about active replication here, right? How well we design this consensus mechanism is very important for us, right? So the consensus that we are talking about for today, right, is the last writer wins or the last commit wins, right? So most of the database platforms, right, whether it is CockroachDB, Yugabytes, PGD from EnterpriseDB, the database that I'm going to be talking about, PGH, all of them have their own conflict resolution strategies and the mechanisms in place, right? But at the heart of it, at the very basic of it, how well you are able to generate these transactions, how well you are able to share the metadata, the authorization, authentication of the data, right? And make sure the database is in sync between them, right? You can say eventually sync, lazy sync, or at a point of time they will be sync or eventually consistent, right? So those are the aspects that you would look at whenever you are choosing a database for your active replication, and you are also going to be looking at how well I can devise my fallback plan, right? The switchover and the failover scenarios in place. Now, from a replication standpoint, like I mentioned, right, we have got synchronous replication, asynchronous replication, the active replication that we are going to be talking about, right? Now, what are some of the best practices that you should have whenever you are looking at an active system in place, right? So you would look at the consistency versus availability. What do you mean by consistency versus availability? Can anybody help me stitch a story around here? From a database consistency or a database availability, how many of you are from the actual DBAs who take care of databases for some of their companies? Yeah. How important is database availability for you? How important is database availability for you? somebody says, I've got, I'm promising you 2 nines of availability, 3 nines of availability, 4 nines, 5 nines. Somebody get crazy and says 6 nines of availability, right? So 6 nines of availability or 4 nines or 5 nines of availability is a few seconds across the entire year. Your system is not available, right? So that's the level of availability matrices or the availability numbers that we are talking about here, right? Now, when we say consistency, right? Now your application developers are processing some data, right? You would want to give them a commit snapshot or a select snapshot for every user that comes into the database and say, hey, this is the source of truth for your database, right? That's what I would call it as a consistency, right? Database consistency. Now, do you have to flip or no, do we have to compromise between these two, consistency and availability? I wouldn't do that. I don't want to lose my job, right? So both are very, very important for us, right? If you go back to the CAP theorem and say, hey, I've got consistency, availability, partition tolerance, right? I would look at consistency and availability. That's what we are going to be focusing on today with today's stuff. And some of the practices, this is from the battle test of my 16 to 17 years of working with these replications and working with some of the customer use cases. So the second point is the most important one, right? The right replication model that you are going to be choosing, right? My friend here says, right, for me, database availability is really important. And I will say 3 nines of availability, 4 nines of availability, right? But what is the exact replication model that you are going to choose? That is exactly what now you are going to be looking at. That looks at that is purely dependent on the application that we choose and the exact use case that we are trying to solve for that particular enterprise application. This is the voice that goes into the YouTube. Okay, now look at the important considerations whenever you are choosing any database platform for you to say, hey, I would want a single primary instance is good enough for me because I've got only 2 nines of availability as a requirement, right? And you also take a look at a synchronous replication as a choice and say, hey, I would need an RPO of 0 and then I can be slightly lenient on RTO point, right? So what is the RPO and RTO? So I'm sure most of you are aware of it, right? The recovery point and then the recovery targets in standpoint, right? So what are some of the important considerations that we should take a look at, right, whenever we are designing them, right? So we are talking about logically replicating databases, one database, one node to another database, right? So what is the first and foremost thing that you would look at, right? All the tables should have a primary key in place, right? I mean, that goes without saying with some of the data modeling principles that we have been following, right? Having a primary key for most of the tables, at least we've got a lot of table types that are available. But when we look at it from a very, very high level standpoint, having a primary key is something that we can, I wouldn't say take it for granted, but it is part and parcel of our modeling standpoint, right? So that's something that we have done. Is the workload relatively conflict free, right? What do I mean by that, right? Somebody in, when I'm from Hyderabad, so somebody from Hyderabad is sending across a few transactions. Somebody from Bombay is also sending across the transactions. Do they have any conflict instigating transaction models, right? So is there a possibility that we will be able to generate some of these conflicts in between, right? So that's your way of looking. Can I have my database modeling around the sequences, right? The sequences size, whatever the data that you are inserting, right? Whatever the data that the Bombay node is inserting, are they conflict free or not, right? If there is a possibility that there will be conflicts, so you will have to look at what is my conflict avoidance policy and what is my conflict negation policies in place, right? So we will come to that in a moment, but that is something to have it at the back of your minds whenever you are designing or choosing what is the exact backup or the replication mechanism you are going to choose, right? Now there are open source versus closed source software that we can talk about, right? Now some of my colleagues or my ex-colleagues, I would say, from EDB would know something about PGD, right? We used to call that as BDR, that stands for bidirectional replication, right? That is a closed source software, but does the entire gamut of things when you are in need of an active system in place, right? Now the ones that we are going to be talking about is a completely Postgres license, which is an open source licensed database multi-master system in place. That is the PGH platform, right? I'm going to be talking about that in a moment. And the last is, how many of you have heard about Postgres compatible engines versus the actual Postgres engines that the replication works on? Anybody have heard about Yugabyte or CockroachDB? Okay, so Yugabyte is a Postgres engine or a Postgres compatible engine? Compatible engine, right? So what does that mean? Does the extensions that we develop on the Postgres ecosystem work on Yugabyte? May or may not be. They are tested or not, they are trusted or not, right? We cannot say that. So Postgres is such a heavily, extension based system or an extension dependent ecosystem, we would say. The extension that we are going to be talking about, Spock, is also an open source extension that adds the capabilities of active replication. Now this is what I was talking about, right? If a system where you have got only two nodes, one primary application and then one database server and then another read replica, this is a solid replication mechanism that you can go ahead and take up. Boom, right now you will start two nodes and then set up Postgres, have a native replication between them, and you will be done in 5 minutes, right? So this is a system that we have been having since 8.4 onwards. 9.0 added a more features, 9.4 added a lot more features. So that's the very basic and the elementary or a foundational building block from a replication standpoint, right? Now we will look at the synchronous replication. The two major differences between the asynchronous and the synchronous replication is, at any point of time you are sending across your commit transaction related metadata back to your primary and say, hey, I am acknowledging all the primary transactions that are happening, and then you can go ahead and go to the next serialized transaction that you are talking about or you are going to be processing, right? The two differences, like I said, one is the commit acknowledgement that sends, and then the second is the wall that gets generated is pretty rock solid between these two cluster entities, right? You will never ever have any data loss with the sync replicas, right? But sync replicas comes with its own pros and cons, right? Pro is obviously RPO can be 0, right? Which means you will never ever have a data loss scenario per se, right? The con would be, anybody can say what would be a con when I say that there is a commit acknowledgement that needs to be sent across. What would be a con? Yeah, please. Right, latency. All right. So when we are looking at the latency as a very big game, right, or a game changer, I said, hey, I've got two of these nodes that are distant, geographically distant. So my latency would go for a toss if I have sync replication in place, right? Now let's just look at the multi-master replication in place. Yeah. So quorum commit. ये नहीं जा रहा है. So if I like 3 nodes, can I say quorum commit is 2? Yes. So, I mean, whenever we are setting up a synchronous replica or a sync replica in Postgres ecosystem, you would always have one async replica also available as part and parcel of the topology. The reason being, if there is any availability issues with the sync replica, the whole cluster goes into a jeopardized state. We do not want to have that. So,
some of things we have two only, like some of the clusters have only two.
yeah, there you will not be able to have that quorum selection standpoint. So it's the no.
Why do we allow that option? We should not.
From an operational cost standpoint, from an operational readiness, or anything, right? Keeping the solution available for all the use cases per se. Yeah. Now let's just take a look at the multi-master replication for a moment here, right? So what we are saying, every cluster entity that is available here is a read-write instance, right? Which means master. So you will be able to go and do all your CRUD operations on both the machines, right? Both the servers in place. That's one, right? And then second is what are some of the things that you need to take care for those instances to be active, for your instances to be read-write, right? So these are the ones, right? So you are able to simultaneously write the data on both the machines, right? So you can have your own application silo here, right? So your entire application container can actually go ahead and have a complete read-write server for yourself, and then you can have an entire application talking and reading and writing to that master, right? So both Hyderabad and Bombay can actually write the database transactions at a same time, and then have a very less or zero latency, I would say, right? So we are trying to solve that problem of latency. Now let's just take a step ahead and say, hey, if my Hyderabad is down, because I'm in Hyderabad, I'm in Bombay now, Hyderabad does not have Harikiran, right? So let's make sure that Hyderabad is down now, right? The application actually can write the entire database transactions to Bombay now, right? So which means my availability problems are also solved to an extent, which means I can just go an up notch and say, hey, I'm not like 2 nines available, but I can be like 99.9 availability, right? So that's one piece that we can add with the multi-master stuff, right? And you will be able to go ahead and do a load distribution, right? What's a simple load distribution, right? Now, whatever the transactions that are coming through, right? Once one site is completely down, you will be able to have, that is all in the connection concentration layer, right? So you will be able to say, hey, all the connections would go to Bombay and then get processed at this standpoint, right? So you will be able to do a load distribution, right? Now, what is fault tolerance? The entire data center, which is part and parcel of Hyderabad, is down now, and still my database is up and running. My application is able to do all the data processing and CRUD operations and stuff, right? So we have a relatively resilient cluster in place, right? So we understood what are all some of the important components as part of the replication: sync, async, and hybrid versus the multi-master replication, right? Does that set a groundwork for us to go a little more and explore all the other aspects to it? Is that a yes? Okay, like I said, the entire solution that we are talking about, the PG Edge Spark that we are talking about, is a complete logical replication methodology, which means there is logical decoding, there are logical workers, there are workers that are trying to communicate between themselves and make sure what transactions are instigated on node 1, go to node 2. So there is an entire mesh that gets created, right? So you have heard about the pub and sub model, right? When I say logical replication, we start off and say in Postgres it is a publisher and a subscriber, right? Now in the multi-master, what we do, a subscriber would also be a publisher, and then publisher would also consume all the subscription data that we are sending across. So essentially a mesh that is getting created between the two nodes that we saw from a active replication standpoint, right? Does that make sense? Right. And this is what I was referring to from, right? So all of it, so we are looking at a few background processes that are going to make sure both the database servers are actually going to distribute the data, persist the data, make sure they are processing the data. If there are conflicts, they will have conflict avoidance and then conflict resolution data types that would come into picture. Right? All of that is what we are going to be seeing now. All right, so this is the platform that I am going to be showcasing today and talking about, right? So at the bottom is the entire database engine that we spoke about, right? The Postgres database engine, right? This is 100% Postgres, right? Has got no compatibility matrices or anything which says, no, hey, this is the percentage of compatibility that we will do with Postgres. No, this is pure Postgres database engine that is available from the postgresql.org, right? On top of it is the two very important extensions that we are seeing, right? So one is the Spark extension. The Spark extension is the one that says, hey, I've got node 1, node 2, node 3. These are the 3 cluster entities that I have, and I will be able to exchange information. I will be able to go ahead and send the transactions that are processed on node 1 to be sent to node 2 and node 3, and then vice versa, right? Now node 2 does the same thing for N1 and N2, N3, and node 3 does the same thing for N1 and N2, right? So that's the extension that is going to help us. Right? Now I spoke about something called as conflict resolution and conflict avoidance in place, right? So now if I say, everybody know about native sequences in databases, right? What do they do, right? Sequence is, I will have a start value and then say, hey, increment by 1, which is to use the PG catalog function called as next val, right? That's the function that will be called whenever there is an insert, right? So you assign that sequence to a column, and then it does a simple job of calling that next val function for every insert. Everybody is aware of that, right? Now if you are talking about two database nodes writing each other, right, and then making those transactions, right, what do we have to do, right? Does native sequences take care of our active transactions? Yes, no? Anybody would say yes to it? The native transactions? Anybody would say yes to that? The native sequences are good enough for an active replication, right? What would be your answer? Yes, no? Obviously no, right? Because there are two database instances that are going to be inserting data. So your native transactions would not be able to solve the problem. But is there a hack that we can do? Something like an odd value and the even value if you are talking about a 2-node cluster? Right? That's the jugaad that we are very famous for, right? So we will be able to do that. But for us to look at the distribution, for us to look at the topology or the availability numbers, and then a lot more nodes that should be part and parcel of that service mesh. So you would look at something called as Snowflake sequence identifier, right? So there are multiple implementations of glog sequences. There are quite a few other sequence algorithms that are available that would help us to make sure you have a next val function as part and parcel of your PG catalog that will make sure there is 0 duplicate records or 0 duplicate primaries that can get created, right? One of the option or one of the approach is the Snowflake sequence, right? So we are not saying this is the only way you can go ahead and achieve the active sequencing mechanism, right? So again, this is a pure Postgres licensed GitHub repository. Everybody can go take a look at it and see how it can generate the sequence values across 3 or 4 or 5 nodes that are part and parcel of your active cluster, right? And anybody have heard about large objects in Postgres? Okay, some of the systems that came from Oracle, right, had these C lobs and B lobs in place. So when we migrated those systems, in the Oracle's, in the Postgres side, we had large objects, right? That is governed by the catalog views. PGLO is the extension, and PG underscore large object and large object metadata as the two tables, which will hold all of that information, right? Logical replication does not take care of our large objects. So we would require some extension for us to say, hey, I've got a node 1 and then node 2, and then node 2 happens to have some large objects in place. For us to have the logical replication supported, you would require the LOLOR extension, right? Again, LOLOR extension is a completely open source Postgres licensed that we can go ahead and compile and use it with or without the distributed systems in place, right? So you have got a data warehouse kind of a mechanism where you are working on large objects, right? Pick up this LOLOR extension and then go about it. And again, being in the conflict resolution ecosystem still, right? There is something called as ACE, which is available, right? Now, this is the entropy engines or the chaos engines that we looked at, right? So this is from any data convergences or the data drifts that happen, right? So we are saying the database is an eventually consistent, asynchronously, logically replicating databases, right? At a point of time, you would want to have that eventual consistency, and you would want to govern the consistency or look at monitoring it and say, hey, do I have the node 1, node 2 and node 3 inconsistent or not, right? ACE is the tool or the extension utility that helps us in making sure the entire database nodes are in sync, right? And apart from that, the PGX platform is, there is a CLI which is based on heavy usage of Ansible and Terraform, right, which helps us in provisioning, orchestrating and setting up the whole cluster, right, that we will see as part of our lab. Any questions up until now or on this particular architecture?
So this POC is like some extra component we have to install.
It is an extension on top of the Postgres database. So this is the Postgres instance, and top of that you will have Spock and Snowflake extension, which will enable that database instance, which will enable that Postgres instance to be an active. So Spock would have two background processes in place, Spock worker and the manager, that will spawn whenever we have the Spock instance. So that extension will make sure N1 and N2 and N3, or how many of our instances we have, are talking to each other.
Like whatever unique ID Snowflake unique ID is giving, that has no relation with Spock.
So Snowflake is part of the database that Spock is installed as. Snowflake is an extension that would help us to generate the next vals for our inserts.
No, but what I'm saying, Spock component doesn't have any.
Spock is aware that Snowflake is an extension and it does generate those next vals for us. If I understand the question, so you are talking about India and Australia and
This is Mumbai and Hyderabad.
Mumbai and Hyderabad. Yeah.
Keep one node in Mumbai and another node in Hyderabad.
Yeah, as long as you have a solid network in place between these two cities, as a matter of fact, we do have that infra. So it should be a good way to go about.
It doesn't require multiple nodes on a single data center.
So from a replication standpoint, right, the overall use case of active replication does work for us, right? But for us to have that resiliency, for us to make sure there is zero data loss, what we would do is, or what is the actual suggested or recommended architecture is to have one node which is the PG Edge Spark node, and then that Spark node would have a sync replica in place. Yeah, in each of the sites that we are talking about, Bombay and Hyderabad will have 4 node cluster at this standpoint now.
So along with four node, do we need any witness node also, or are we going to form a forum and consensus between this or any?
So Patroni is at the back, which is Patroni and HCD are the ones that are part and parcel of the orchestration. So Patroni and HCD will help us on the quorum election standpoint. So when the PG Edge node is down, so the sync replica is automatically upgraded and acts as the PG Edge Spark instance.
Second replica would be we can keep it as a sync.
We often recommend that to be a sync replica from an RPO standpoint. Does that make sense, folks? Right. So from a, yes, please.
But I have seen from my personal point of view from projects now clients who are moving into clouds, they don't want this kind of architecture to be a simple because they are using the cloud native architecture.
Okay.
Because administration point of view also it becomes less comparatively with having a DBA handling the entire cluster rather than there is a single node and the cloud native replication takes place. How do you see now from a future standpoint? Is this the way it's going on?
So, I came into IIT and then tried having my laptop connected to the Wi-Fi, right? And then they strictly said it is an air-gapped system, right? So there are compliances, right? Every domain has its compliance, every industry has its compliance, every enterprise has its compliance. If the enterprise systems are good with endpoint having, hey, I just need an endpoint where I can just push my data, read my data, boom, my work is done. For those things, right? Yeah, no, the cloud native ecosystem is super cool, right? They don't need a DBA. Everything is taken care by companies like AWS, RDS, or GCP Cloud SQL, or Azure flexible servers, and now the new ones, right? But if you let's look at a little more availability coming into the picture, right? A little more complexities of the systems that are coming into the picture, right? At that point of time, your single node instances are not good enough yet, right? Again, it is by use case, compliance by compliance, and then you can look at what is that you need, right? Do you need extension support, right? Do you need a lot of zero cost for egress and ingress, right? Your cloud cost is had to be as less as possible. Do you want to be on a hybrid system, right? When some of these US East one goes down, entire world goes down, right? So do you want to be in that, right? There is again a cloud concentration risk. So all of these are some of the things that I'm not trying to convince you that cloud is good, cloud is bad, on-prem is good, hybrid is good, right? I'm just putting forth what is it that your customer requires, what is it that the enterprise requires, what are the use cases that we are solving, right? Does that make sense? Okay.
But this nothing does not mandate synchronous, right? We can even go for async.
You can, yeah. It does not mandate it, but we as an architectural recommendation, we want to have a sync replica in place. Right? Now looking at the
Your geographical sharding, right? That can help for
yeah. So some of the please. I'll just handle come back to it. So another point that the gentleman just alluded, right? The geographical distribution, right? If we are on cloud, clouds do not have the distributed databases yet, or the active stuff yet. Google Alloy DB has, and then some of the other clouds in conjunction with EDBs, in conjunction with PG Edge, in conjunction with Cockroach, and all of them have these cloud offerings. But one important component that most of the cloud platforms are missing is the edge compatibility, or no, the edge features that the users want, right? For all the applications, we've got the Cloudflares, Fastly, Trustly, and all of these things, right? But that does take care of the CDN from a application standpoint. Who's going to give us the edge computing and the edge databases, right? So we need to have that multi-master or an active replication for us to even go ahead and say we will be edge compatible at the database layer also, right? So which means that you are getting a transaction, you have your cluster with one node in Bombay, one node in Hyderabad, one node in somewhere in Himachal. So you have all the directions covered, and you have the capability of knowing what is the nearest node for you to send that transaction, for you to send that right transaction to. Somebody who's processing the data from Delhi will go to Himachal, right, because it is closer. So that finding the nearest node is something that we are bringing about as a geographical distribution, and then finding it more and more latency friendly, I would say. Yeah, please. Anybody who's serious about their data? So BFSI is something that I would really look at as one of the domain, and online services will be the second one. Healthcare sectors are somebody who are really interested in saying, hey, I have got my research data from John Hopkins, I've got my research data out of ABHA, out of my Indian ecosystem. How do I make sure all of these are talking to each other, how these transactions are happening, right? So when we are looking at some real-time healthcare data being processed, distributed databases are pretty heavily used there and relied upon. Okay, coming back to the configuration fundamentals, right? So we have got three components here, right? So one is the node. The node is the one we are going to be creating as a server instance, where you will have Postgres, you will have a data directory, there is a port in place that we are going ahead and talking to, right? So that is the node which will have all the binaries of Postgres, PGDay platform, Spark, Snowflake, everything. On all the nodes you will have them, right? And then there is something called as replication sets, right? I spoke about something in the start, which is primary keys, right? All the database tables should have a primary key, right? When we are enforcing that rule, right, we are giving the developers a pain of making sure all the tables have primary keys, right? So there are scenarios where you will not have those primary keys in place, right? So you can say that those tables are append only, which means we do not need to take care of some of the DMLs like updates or deletes on them, right? For that you will have a replication set called as insert only, right? For all those tables which does not have a primary key in place, you will have a insert only replication set, right? All the database transactions that are going and going between the tables which does not have a primary key will use that replication set, right? It is an additional feature to the developers and then the data processing ecosystem saying, hey, I've got nodes and then I've got tables and then tables who have got primary keys and no primary keys in place, right? That's just solving one less problem, I would say, right? And then the subscriptions, right? This is the mesh that I was talking about, right? So node 1 is a subscriber, node 2 is a subscriber, node 3 is also a subscriber, right? They are subscribing the changes, the DML changes that are happening between themselves, and then they have their own replication, right? The logical replication streams that generate between the node 1, node 2 and node 3 is in place. And we'll come back to this configuration parameters that makes sure how the whole replication is done and how the replication will be done. So most of you all have got the the runbook that I sent via email. I mean, I had like ton of bounce emails from some of you. Probably there is a special character in the emails or no stuff, I don't know, but I tried to cover as no, detailed as possible, as step-by-step instructions as possible, right? My colleague here said, Shamal said, hey, you are using an AMI which is with respect to Rocky, with respect to Ubuntu or stuff, right? So this is purely on Ubuntu, right? So if you are using an AMI, the EC2 instances, something like a Rocky or some other RHEL, you just have to make those changes, right? And thanks, Amal, for that note. So I'm going to skip the setup, which is the Ansible related one, and I'll jump to the actual Postgres installation, the PG17 setup, and the Spark setup in place, and then we will jump to the actual EC2 instances where I've got all of that stuff. So what we have here right now, when I showed the PGDay platform, there is this CLI that was helping us, right? Now the orchestrator. So this is the entire Ansible orchestrator that we have. All right, so I am looking at this, from a platform standpoint. What are all some of the platforms that we will be able to support, or where you will be able to go ahead and set up the servers, where you will be able to go ahead and have the nodes that are there in place, right? So the CLI is what I'm talking about, and this CLI has a pure, I would say, an Ansible way of setting up the whole cluster, right? There are other ways of doing it, right? You have manually setting up the cluster, right? How do we go about creating one node with a set of subscriptions, right? There is a lot of customization that you can do. What we are going to see here is a plain Ansible way of setting up the whole cluster, a 3-node cluster in place. Now, this is a very easy way of interpreting the JSON file, right? Now, I don't know. Ati, you are able to see the font clearly? No. I don't know how I can increase this. Looks okay now? Okay. So this is a very simple YAML file that I have got, right? This YAML file is going to have all the host information, right? What are all the number of hosts that we have in place, right? We are setting up a 3-node cluster, right? And what is the role of that specific node that we have in place, right? And then where is the zone that we have created, right? All of them are inside the AP South zone, which is the Hyderabad zone that I created all of these 3 instances, right? Now these are some of the metadata for your connection layer, right? So how do I connect to my database servers? How do I make sure the communication between the nodes are happening? And Deepak had asked about what is the connection concentration layer that we should have, right? How are the applications going to interact with the database, right? How do we make sure some of these connections come to the come to the servers, come to the transactions are going to happen on the databases, right? So we have got HA. So we have got HA proxy also here. So these are the 3 HA proxy servers that we will be interacting with. The applications will be talking to these HA proxies and then sending across all the transactions. So every database node will have an HA proxy in front, and you will be able to send those transactions, you will be able to make sure all the transactions that are sending across have got zero or as less latency as possible, right? So once we construct that, so what I'm going to do is I'm going to send you all the YAML files, both the inventory and the playbook.yaml file. No, it is actually available on the GitHub repo also, right? So I'll point you to the GitHub repo. You don't need to do any changes per se, right? You have fetch the IP addresses that you are going to be setting up your nodes on, replace them in that node section, and boom, right? Just use these commands that I have in place, right? So whenever we are looking at adopting to a new system, adopting to a system, how do we make sure the user experience, right, for setting up those systems, right, setting up those database nodes, setting up those Postgres instances are as easy as possible, right? I have heard a lot of TPA exec that I have developed with Abhijit, but similar to that, we have got an Ansible way of orchestrating the entire setup here. How many of you have done Ansible way of setting up Postgres instances before? Anybody who have seen Ansible way? No, not you. No? We have done this like 1001 times. Anybody who uses Ansible? Not you. We have done. Anybody else who have seen Ansible way of setting up infrastructure as a code, right? Basically making sure everything is coded as part of your YAML files, and use those YAML files for us to provision that stuff. Right? This is exactly what is happening. So we are going ahead and installing Postgres. So let's go back to this. Right? We are going ahead and installing the Postgres database, and then we are installing this Spark, we are installing the Snowflake extension, and making sure the entire cluster is ready for us from a 3-node database, three nodes as part of our cluster. Yeah, so you will go to the inventory.yaml file on the Ansible standpoint and say, hey, this is the new node that I have coming into the ecosystem. Give the credentials and then the host information, and boom. Because Ansible or the Ansible's IAC, right, is completely idempotent, right? It does not change anything which is existing, but whatever is added is getting is taking the precedence and then doing all that activity with respect to only that new node. Sorry, how? Huh. So that's the beauty with the Ansible ISC code that we have written. So if we take a look at this one, so if I take a look at this one, right, one node should have the Spark, right, Spark, and then the snowflakes that should be there, and then the replication that needs to be there, and the subscriptions, right. So now we have got a 2-node cluster. Assume that we have got a 2-node cluster, and we want to add the 3rd node. So the 2-node cluster is up and running. Ansible knows that it has got the YAML file, everything from an ISE standpoint is available. Now we are introducing another row or insert another cluster entity to that YAML file. So what it does is it looks at the current status of the entire cluster. it identifies that there are two nodes. So which means N1 to N2 subscription and N2 to N1 subscription are available, right? They are talking to each other. Now what we are introducing is the third node. So the third node will take a backup from the source of truth. We will be able to say that, hey, Bombay is the source of truth. So take that instance. Node 3 will connect to the Bombay node and then take a backup.
This also will have master, primary, and
so the third node could be added as a sync replica, an async replica, or a complete master node also. So you have the roles that can be defined in the Ansible. So whatever the third node that we are adding, now let's assume that we are adding it as a PG Edge node, right? PG Edge multi-master node. What we are going to be doing is, we are going to be creating the rep sets, we are going to create the node, and then making sure the subscriptions are going from N3 to N1, N3 to N2. And N1 is also registering N3 as a new cluster entity. So you'll have N1 to N3 and N2 to N3. So all of the 9 subscriptions are going to be talking to each other now. So and everything is a foolproof mechanism where you will have to pause the replication to not have the race condition in place.
If we have lot of data,
Hmm.
will it take long time to do this, like new node addition?
It does a PG base backup in the background. So PG base backups are relatively tuned to a good extent. Yeah, it does take time. Now we are talking about a 1.5 terabyte database, right? Taking its own, 35 to 40 minutes of time. Yeah, it does take time. Correct.
All those replication slots will be communicated to in a mesh topology.
Yep. Yeah. Every one of the subscription will talk to them in a mesh topology. Again, we are simply talking about the logical replication that is available in Postgres, right? They have not reinvented anything from a logical replication standpoint, right? And it does not make any sense to reinvent the wheel also, because we have got all the, logical decoding plugins are available. Every bit and piece that needs to be in place to do that logical replication is all available. So we are just taking that into the Spark and then making sure how we can have the conflict resolution and conflict avoidance. That's it. Nati, you're going to help me if you're able to see the screen or not. You're able to see the screen, right? A little more, maybe. I'm being stingy here. Right. So this is the whole PG Edge specific binaries that we are installing, right? You can see that I have the Postgres engine, right? Postgres engine with PG17, right? PG17 version of it up and running, and you have got something called as Spark extension here, and you have the Snowflake extension also, right? So that is the bare minimum setup that you would require, that is required for us to go ahead and instigate that my active system in place, right? I've got all of these on the 3 node clusters that I have in place. So this is the node 2 and this is the node 3 that I have. Now let's just take a look at some of the foundational building blocks that we have seen, right? The nodes that got created, the replication sets that are there in place, the subscriptions that got created, and so on and so forth. The database that, okay. The database that I have created on all the three nodes is MMRDB, right? Now, how do we look at the extensions that we have available in place, right? So the Spark extension and the Snowflake extension that we have, right? So these are the two extensions, and what are the versions that we have in. So let's just take a look at some of the tables that we have in place, right? What are some of the metadata tables that are part and parcel of the Spark active replication, right? So if you take a look at some of them, right, let's now focus a little bit on this. Some of the tables that are part of it, right, will help us to make sure that sanity from an active transaction ecosystem, or the control that you would want, or some of the conflicts that you would be able to generate, and look at what are some of the exceptions that you would get whenever you are looking at a insert conflict, insert update conflict, or an update conflict, right? All of them have to have some place to go to for us to take a monitoring snapshot of it, right? For us to take all the observability data for us to see, hey, how is this system being behaving when we are pumping transactions, right? Are there any exceptions in the database? Are there any conflicts that we have instigated, and how we are resolving them, right? So you have got this something called as conflict resolutions and the exception log. So these are the two tables that you would hook it up to your monitoring system and say, hey, get me all the latest and greatest data from these two tables, exception log and exception log status, and make sure that there are 0 exceptions at any point of time, right? If there is one, you would look at the resolutions table and say, the exception has been generated, but is it solved on the target node or not, right? Is it resolved on the target node or not, right? That is the resolutions table. So we have exporters available, Postgres exporters available, a forked version of Postgres exporter that is aware of these Spark tables. So when we hook it up to our Prometheus, it will gather all of that information via that exporter, and you push it to Grafana, and Grafana will be able to showcase that for us. So that's the platform monitoring that is already available. It is available. Yeah, it is available. So you have to just download that Git repo and then make sure Grafana is available at a port, Prometheus is available at a port, and then there is a node exporter also. Node exporter is a pretty cool extension that folks have written from Quay.io that helps us in generating all the node level statistics and observability data, right? My CPU, my RAM usage, all the uptime information, and so on and so forth. Now this is the node information that I was talking about, right? The 3 nodes that we have set up, all of the 3 nodes will have these information in place, right? What is the node that we have provisioned? What is the nodes that have some of the subscription sets, right? The replication sets. What are all some of the subscriptions that are available in these, right? Let's just take a look at that subscriptions. Right? Now just take a look at the subscriptions that we have available, right? So we have got 3 nodes here, N1, N2 and N3. What we have is the first subscription is from N1 to N2, and then the second subscription is going from N1 to N3, right? This is the same thing that you would see on the other databases also. right? So take a look at the subscription naming convention here. I am on node 2, right? And how do we take a look at all that Spock info, right? I am on node 2, and then these are the two subscriptions that I have in place, right? The two subscriptions are N2 to N1, N2 to N3, right? The whole ecosystem is available on all the three nodes, right? The nodes that got created, the subscription sets, and the replication sets that are there. So these are the replication sets that I was talking about, right? So the default is the one which will always take care of all the DML transactions that are constantly being, processed by the application, right? The only prerequisite for us to have is primary keys on all the tables that are assigned or that are attached to this particular replication set, right? And then anything that has insert only, right? Where we do not do any DMLs like updates or deletes, can be just assigned to this default insert only rep set, which means you don't have to change the application schema or the way you are you have designed the whole schema of, hey, I want some tables to be without a primary key because I just don't care about any transactions on them, which is like changing the data. It is always an append only. So we are not enforcing that primary key rule per se, right? So we will be able to add the tables without a primary key to that insert only, right? How many of you have looked at the native logical replication and say, hey, I do not have a DDL replication, right? All the DDLs that I am doing on my primary system are not being replicated to the logical replicas in place, right? I have had that pain, right? And whenever we are looking at delivering a rollout, an application rollout which has got all of DDL changes, right? I will have to stop my logical replica, right? Disable the subscription in most cases, right? Do all these DDL activities in place, and then go about enabling the subscription, and then wait for that subscription to make sure, okay, the XID and the LSN that is there on my primary is also the consistent LSN on my logical replica, right? So I have been on those calls in those application rollout calls. But with the DDL SQL replication set as part and parcel of Spock, so we have solved that, right? So there is automatic DDL that is happening on the machine, right? Which is all the nodes, the N1, N2 and N3 has the capability of making sure all the data can be, all the DDLs and DMLs can be going. So essentially we are looking at a multi-master active-active system, both from a DDL standpoint and a DML standpoint, right? So that's the one use case that we have had a lot of problems and then a lot of requirements that we were able to solve with Spock.
Any issues with logs? Any issues with logs?
Any issues with logs, right? That's the experience of a DBA who's coming up and saying, right? So whenever we are doing these auto DDLs in place, right? So it is governed by a few parameters. Again, the parameters that I wanted to talk about. The font is okay, right? So there are a few parameters that we can talk about, right? Something like enable DDL replication. I don't know where it is, but there should be one. Enable DDL replication, right? So whenever you say that I am enabling the DDL replication, I want the DDLs to be done only on N1 and they should be reflected and applied on both N2 and N3. You will make sure the enable DDL replication and the include DDL rep set. These are the two parameters that Spock gives you, and then you have the control of whether to enable them, disable them, enable them only when you are doing your application rollouts, and this requires only a SIAP signal, which is the reload of the configuration, right? So you will be able to control the auto DDL standpoint, right? For some of the shops, where you want all of the DDLs to be going left, right, center, right? You would enable them. But what to do with auto DDL and what not to do with that auto DDL is something that comes with experience and after burning your hand, right? So you would go ahead and add a column with a default value, right? That's going to rewrite the entire table, assuming that the table has got 10 million records. So you will have to rewrite that entire table for you to apply that DDL, right? So for that, what we have is something called as there is something called as queue table, right? So this queue table is very, very specifically for queuing all the DDL transactions that are happening on the database, right? So queue will make sure that whatever the DDL that is applied on N1 has that lock and latch management taken care between N2 and N3. So those tables on the N2 and N3 will have a log from a DDL standpoint, but it do not cause any DML logs per se. So you are doing, the DDL transaction on node 1, and then table is transactions table. The transactions table on node 2 and node 3 will have a DDL advisory log, but does not impact the incoming DML transactions on them. So that part of the story is kind of sorted out. Again, somebody who wants to do DDL would do only on one node, and then wants to make sure all the other nodes are taking it and applied together.
So that queuing, this queue table will handle that table log.
Yeah. Queue will make sure all of that is logged and then monitored and makes sure that that same table is not taking the same DDL again. So you should have that guardrail mechanism that the same command, right, the same SQL script. We've got database migration tools like Flyways and then Redgate and stuff, right? Those tools should not have access to that specific transactions table on N2 and N3 to go ahead and run that DDL commands. So you will not be able to do it. It just says that this particular table is being carried out, and you will not be able to generate any DDLs or execute any DDLs on those tables.
Will that not be going to generate some inconsistency, data inconsistency
So this is from a DDL standpoint.
for DML?
DML it does not. No, it is a pure. That's why we said.
One node goes down out of the 3 nodes.
Uh-huh.
If we fire in DML.
So you are saying N1, N2 and N3, N1 completed the DDL command, right? So that is captured as part of your wall, and then that wall is translated, applied on N2 and N3.
My N2 or maybe N3 is not available, not reachable.
Uh-huh.
So what will happen?
So your walls will be withheld by the replication slot, right? That it's the whole Postgres wall architecture that is used by Spock. So that part of the reliability does not change at all, right? So it is part of your walls, and replication slots will withhold that. And then once the N2 and N3 are available, hey, I've got both N3 and N2 cluster entities available, right? Let me just send those walls again and decode them on N2 and N3.
So this is all like captured from the log file, right? The DDLs are all captured from the log file.
As long as we have logging underscore statement.
Even the Spock,
Spock has its own logging per se, and then it also uses Postgres logging, log underscore statement, log line prefix and stuff.
so our DDLs are captured from the log, right? Not
I did not quite catch that.
whatever DDLs you are applying,
Huh?
the Spock component reads from the wall file.
That's correct, yeah. So queue will hold all the records that I have not applied this DDL on N2 yet. I have not applied this DDL on N3 yet, right? Once the queue will be, done and dusted, right? It is applied on N1, N2 and N3, and from that DDL statement standpoint, if everything is done, queue will be cleared automatically.
this shield can be used for other products also, or
I mean, this is just exposing via an API and say, hey, if somebody who is trying to look at this DDL statement to be made available by the other,
why
uh,
I'm asking IBM series is there. We say we don't support DDL.
right. I mean, in the native logical replication, also we don't support the DDL replication yet. I don't know, God knows, 19 will help solve us some of them. But we have solved the sequencer side of the story in 18 that I guess Deepak has blogged about. But from the whole DDL standpoint, it's not yet there. We will get there. But the Spock extension has resolved it already. Right? I know we are at the top of the hour. I wanted to have at least 10 minutes of question. Any questions that I can take?
Sorry, you tell me one thing. Is this tested on a high volume performance?
I cannot name the customer, but we are looking at a stock exchange. So stock exchange does pump in some decent amount of numbers, and TPS, yes.
But all these problems with sequences, etc., typically in node architecture, my sequence is generated and for OTP generation, etc.
Right, right.
So if my it's order kind of thing or disorder kind of thing, depending on that, there's a lot of conflict can happen.
Right. So all of the conflicts can be, you will be able to use the available CRDTs, right? They are called as conflict-free resolution data types, right? So you will be able to use those CRDT data types that are available in the Postgres ecosystem itself, in the Spock itself, and then make sure your application is working hand in hand with those CRDTs, right? The conflict resolution that it applies is last commit wins, right? So you are good with that or not, right? From an application standpoint, is it good with that or not? You'll have to ascertain that. And then go have your own, and it also allows customization of those CRDTs. Somebody says that marketing gets paid first, sales gets paid last, right? That is an application logic or a derivative that we are putting on the table. So similarly, you can code that logic. Similarly, you can code that thing in place and make sure, hey, this is the conflict resolution logic that I want to implement for my application. So it is use case specific, but the infrastructure that you need for you to have a conflict free is already available.
I would suggest, you guys typically, I know you are excellent in this thing. Typically, I feel that design part become a very tricky.
Yeah.
Because I need to
the discovery is very, very important.
Last updated, last inserted, so all columns should come because my microservice architecture to understand this concept.
Correct, yeah.
So it will not only happen on the database level, but on application stack.
Yeah, there has to be a marriage between the application and.
I should write down some blogs on that one.
There are few blogs available that.
That will
Sure.
primary base architecture you have already created, but
Yep.
when it comes from the application, I think we have worked with last step from typical problems should be always there. So if there is a guideline from the beginning,
Sure.
I feel that Manish already covered that logging issue typically seen in the high volume transaction.
Right.
This will also get addressed.
Sure.
This is fantastic. You are going ahead with NoSQL kind of thing where I don't require downtime for adding columns, etc.
Right.
So that's fantastic.
Cool. I know we are at the top of the hour now. Unless and until Somnath is chasing me down, I can go a little more. I think. Yeah, please.
So instead of asking questions, like if you could just add some do's, don'ts, standard practices for this one.
Right. So what I would say is make sure when you are designing this active system has got, say you are talking about 2 sides or 3 sides, right? The way I would go ahead and design the system is at least 3 nodes on one of the sides, right? So one side will have a PG edge node, which is the active always. So all the 3 sides has 3 active nodes. They are talking to each other, right? From a data or cluster resiliency standpoint, right? So we will have one sync replica and an async sync replica, right? All the reads can be happening on the async node. I don't know, the sync replica is always from a ultra HA standpoint, and making sure this sync replica can take the promoted role of PG Edge multi-master node at any point of time whenever there is an incident or a planned switchover or a planned downtime that you would want to have. Again, this is all in conjunction to 4 nines of availability that we are trying to promise to the applications. Again, no, this is what Deepak also asked, right? What is the underlying infrastructure in place? So we've got Patroni plus HCD that is taking care of that whole quorum election and the HA part of it.
How many nodes can be there? I mean, minimum 3 is required, or
Minimum 3 is something that I would always recommend.
any testing done on the
The 24 nodes across multiple AWS availability zones is what we have done as of now.
As a standard setup,
3 nodes is something, yeah, 3.
if you're thinking of Petronic grounds, so
You need 3 nodes in that particular site. Yeah, HCD.
with Petronic we can go ahead.
Yep. HA proxy will take care of your connection concentration layer and then making sure, hey, the site 1 is temporarily down, right? I'll route all of the site 1 connections to site 2 and site 3 per se.
Even if we have this solution in place, so basically clients do not get convinced to go for any of the downtime with this thing.
So you got to just plug off your entire site and say that hey, this is transparently going from site 1 to site 2. Right? That's the best thing you could do, right? And I've done that. Yeah. Go ahead, please. The 24 cluster is 8 sites that we have done. 8 into 3 is what we have, 8 PG edge nodes, and the other 8 are sync replicas and the other 8 are async replicas. In multi-master, there are 16. All right, I guess Deepak is ready to kick me out of the room. Thank you so much, folks. I will be around for the whole day. Please reach out to me.
Hello. Uh, Very good morning, everyone, and thanks for making here that too on weekend Saturday. Uh, and when we started PG Mumbai, we wanted to bring Postgres to Mumbai, and that was the core motto behind starting PG Mumbai altogether. And seeing a room full with people who are Postgres enthusiasts, veteran, newbies, and all, it gives us a lot of excitement to take it at a different scale. So thanks for making it on Saturday. So yeah, just clap for yourself. Okay, so now we'll start with a very small exercise. I want everyone to stand up. Everyone. Okay, and this is very important. Okay, thanks for it. How many of you are using Postgres? Just raise your hand. Awesome, most of them. Whosoever is not using, just sit down. Awesome. How many of you have less than 1 year of experience in Postgres? Just raise your hand. Awesome, you can sit down. Yeah, thank you. How many of you have less than 5 years of experience in Postgres? So people have to look, okay. Raise your hand. Awesome, sit down. How many of you have less than 8 years of experience? Thanks a lot. So now look at the faces of people who are standing here, okay? These are the folks you need to talk to. Okay, so they bring in a lot of experience. They are here with us, here to share their experience, and I think you have to look all of those faces who were there, right? So make use of their time, and once their talk is done, in case they're speaker, go and talk to them about their experience. Thanks for it. Yeah, sit now. So we started at a very important place in Mumbai, which is in BKC with Google, with all support from Tushar, who is from Google. So I'll just hand over to him and just to give you a glimpse of what happened in our first meetup that we did in BKC Google office.
Hey, thanks, Deepak. And good morning, everyone. Good to be here and good to have you all. Uh, it's a privilege to be again being here on the stage to talk about like how this whole PG Mumbai thing originated, and we are now in the second edition of it in a quick succession, I would say. So the first event that we had in our Google office, that was in November of 2025, and I very precisely remember like Deepak reaching out to me. Now Deepak was an ex-colleague. He had worked with me in Google Mumbai office, so a dear colleague and now a good friend from industry as well as on personal front. So when he reached out with this idea that can we do something to get started with this whole PG community movement in Mumbai, I was like equally excited because I just recall the type of discussions we used to have in customer context, the technology context in our uh, days back then, right? So it was a no-brainer for me to just kind of put the things and act together and see like how at the earliest we kind of get into it. So Ajit, Shaw and all, we just met, we just decided on the logistics and the date, and we did it. So purely the experience was phenomenal. So it was kind of a first time event for me in our Google office. So we do keep hosting different type of events which are more customer centric, and the conversations are very different, but this was like more the community feeling that was coming up, right? So the type of discussions we had, the speakers we had. So I had coincidentally a couple of colleagues, senior colleagues from development and engineering who were visiting from different parts of the world, and also from other, I mean, like collaborating companies. So we had a very nice event where we kind of just what you call spoke about the industry interface, like how the industry is seeing the adoption of Postgres, how Postgres as a DB engine has like really flourished in last more than a decade or so, right? So until then it was more like commercial databases, and then how this whole momentum has picked up and how we have progressively kind of gone ahead. So I think it was a very good starting point, and it, I mean, not even before the event ended, we just started like, when are we going to meet up next, right? So, I mean, that was the inertia and the excitement that we were kind of running with. So, all thanks to the organizers again that we came up with this venue and this wonderful event again. So, yes, please make the most of it. I think by the end of the event, you will know everyone over here. If not, I mean, like, please reach out, and let's see how we can kind of take the momentum forward and make PG Mumbai a big talked about event at India scale, if not beyond, right? So thanks, Deepak, for having me, and let's make a good use of this platform today.
Thanks a lot, Tushar. So I'll just presenting the DB engine ranking of Postgres. I think most of you, if you're not following, it is something that is catching up as part of the relational or de facto database. I always refrain from saying that Postgres is a database. It's not a database. It's a framework, it's an ecosystem, it's a thought process, and in Gen Z word, it's lit. So it's like something that you all want to use it and all, right? And I'm I have so much affection for Postgres. So if I see a messy room, I don't ask to clean. I ask my mate to do vacuum analyze. So it's so it's like, yeah, so we all have that love, and that's what we want to carry forward as part of our event as well. Okay, so the schedule that we have is we'll start with a keynote by Professor Prabhu. He is here, so I'll not take much time. And then we have set of talks from different speakers. So we'll have 3 talks before the lunch across 3 different areas, including search, analytics, and most important topic, performance and all. And then post lunch, we have some more talk around it. So the event will go till 4, and you'll have lots of talk. And then at the end, we'll have lightning talk as well. Okay, so take the most of the event, talk to the speakers who are coming on the stage, use their experience to get your problem or curiosity on any of the technology. Okay, so just so this is the schedule. Okay, so I'll just not take much time. I'll request Professor Prabhu to come here and start with the keynote. Yeah. Thank you. You can continue.
So good morning, everyone. It's actually really nice to see a class full of people excited about Postgres here. It turns out that I actually teach class in this very same classroom this semester. And I'm supposed to have a class of 110 students. Maybe 30 show up on a working day, okay, or 40 show up on a working day. I hope it's not a reflection of my teaching. I don't think it is, but okay. So welcome to IIT Bombay campus. How many of you is your first time here? Okay. Wow. Okay. So this is like when you come into campus, it feels like it's a new place, right? It's not Bombay, right? So yeah, we are very privileged to live in this campus. It's a really nice campus. Just step out, you get the full chaos of Mumbai. You just come back in, you have the tranquility of this campus. So welcome to IIT Bombay. So I am Prabhu. I am a faculty member in IIT Bombay, specifically in aerospace engineering. But I have dabbled a lot in computational, I work in computational science. But because I do a lot of computation, I've been playing with computers for a long time. maybe 30 years, more, but anyway. So I am not an expert on Postgres, okay. I am a user of Postgres through various things that I happen to do, but I'm not here to talk about Postgres, so don't worry. I'm not going to bore you with stuff that's wrong. I'm here to talk to you about digital sovereignty with open source software, and I think this is extremely important. In many ways, this is very timely. Some of you might be wondering, is it so timely? But maybe I'll answer some of those questions. So why am I being called here? Well, I am actually the current PI of the FOSSEE project. I guess this organization is happening through the FOSSEE project. And also a sister project of ours, the Spoken Tutorial project, actually has a whole course available for free online for anyone to take on Postgres. So that's the reason I'm standing here before you. All right, so what is this digital sovereignty? I think everybody knows this, right? So just to make it clear, it's not just software, it's not just data. So it's basically data, software, hardware, and infrastructure. The ability for a country or a nation or a city or even a state government to own all of this and have complete control over this, right? This is what digital sovereignty generally means. So that's the topic of what we're talking about. So why is this relevant to us and why is this relevant today? Well, obvious reason is one is finance, okay? Which means you own everything, you don't have to pay license cost to anybody else. But sometimes it works the other way. A cloud provider can basically say, hey, wait a minute, I'll give you this for free. We all know that the reality is that if something is for free, you are the product, right? So free is not necessarily without strings attached. But the more serious issue is that there is actually a strategic importance in some of this. And a lot of these, I'm going to narrate a bunch of stories that show you that this is not that, it's a very serious affair. So let's look at, some of you are going to be like, really in 2026, is this a real problem? It is, okay. So it turns out that there are several places that have decided to completely move to open source software. So one of the cities, so this is an article in ZDNet and it's not old, it's June 27, 2025. And Stephen Vaughan seemed to have a lot of articles along these lines, so he's a good person to track. So the city of Lyon in France basically dumped Microsoft and decided to switch to only Office and Linux, both open source software, okay. So entire city says, I'm not interested in using this, and it's not just a financial argument again. Okay. So this is an easy case. The next is an entire country. So Denmark as a whole, again this is June 11th, maybe a bit before this, the entire Danish government is announcing that it doesn't want to have Microsoft Office and Windows controlling all of its equipment on all of government related resources. And the reasons are kind of obvious because we all know it's not just Trump. I think Trump is one accelerating factor for all of this, but it's always been there in the background. If there's a country that can essentially, or a set of countries that can shut you down, that's a problem. And all of these countries that I'm going to be talking about essentially have done this for the same reason. They want sovereignty, they want control, they do not want some external agent to that country actually lock them down. Third example, the European military, there's an Austrian military specifically. The Austrian military again decided to ditch Microsoft for open source LibreOffice. Okay, again, so you can imagine the entire military complex is saying, forget about proprietary software, we want digital software. And here the reason is definitely not financial, right? Military budgets are huge, so it's not financial. Again, the argument is they don't want somebody else to lock them down. And then there is, this is a very recent situation. And now I'm not justifying Israel, okay? Let me be absolutely clear here. I'm not justifying war or anything or, genocide, none of this. I'm simply saying as a country, they had a unit, I think unit 8, I don't remember the details, but yeah, this article, you can search for this, Microsoft blocks Israel's use. Apparently one of those units was doing a lot of surveillance of people in Gaza, and they had uploaded all of their data to Azure. And Microsoft found out because of The Guardian did a story on this, and they locked them out, like entirely locked them out of all services, okay. Now, some of you may say, yes, good thing. Some of you may say no. But the point is, if I were somebody in Israel, in the government running this operation, I would be worried because then somebody else has control over my data and they can shut me out of this. It's another serious problem. So if they're doing something for anti-terrorist activity or God knows what, they are essentially locked out of it. Okay. Once again, not justifying anything. I'm just saying that this problem exists. But this is not just abroad. This happened. This also happened in India. So I don't know if you've heard of this company called Nayara. They are not a small chotu-motu company. Huh? They are the second largest private oil refinery company in India, accounting for about 8% of all refinery operations in the country. And for about a week, I have the details later, they basically were shut out. Okay. So in 22nd July, Microsoft, based on some 18th of, there's an embargo on India because this company actually has some ownership in Russia. But whatever be the reason, they were locked out of Microsoft 365, locked out of Teams and all their data that was with Microsoft until 30th. So on 28th, these guys actually filed a case with the High Court. But then by 30th, Microsoft backed out and then they withdrew the case. Okay. The thing is, this is, you can imagine, it's a company which has like 8% of India's capacity in refinery. If they're out for a week, it's a huge financial loss. So yes, there's a financial argument, but then there are lots of people. So in fact, I got called by Ministry of Home Affairs for something, right? Because everybody got shook up saying, look, if someone can lock us out of operations and you have this huge financial loss just for one company, imagine if, you know, Trump decided to say, okay, I want to annex Kashmir. Okay, God knows, he may get that idea tomorrow, right? Right? And say, I want to annex Kashmir, I'll bomb, nuke Pakistan out of the picture and I'll come and occupy it and we'll lock you out of it and do whatever it, he could in principle do it. Okay. Oh, okay, then even worse. There's a very likely chance that he's thinking about this. Okay. So, say this is a real problem. So, in fact, the government is concerned. A lot of our technologies rely on external, right? So, if you look at all of the traffic that's going through, probably a Chinese chip or, you know, that's running my network, the entire network of most organizations. In fact, India does not have many native manufacturing for high throughput network equipment. Okay. Wireless routers, same issue. Okay. All of our computers, right? Yes, we are now, so we're getting there. Okay. So this is a serious concern. And with the global, you know, situation going in all kinds of ways, we would never have imagined. There's been a war running for what, 2 years now? I can't imagine. 4 years, Ukraine war is like madness in 2026. You thought this is all behind us, World War, bahut purana zamana ka, it's not Africa, it's not. So it's now, it's back to square one, right? Everybody is economically trying to. So the point is, this is a real concern, okay? So the one way of getting out of this, you know, is that we move to open source, okay? So open source is one way which in principle you can get out of this, because okay, let's say they knock you out of GitHub, by the way, is owned by Microsoft. Okay, doesn't matter, but I can fork it and I have a full copy with all the history. So if I want to, I can fire up another clone of GitHub here, not of entire GitHub, or at least of the libraries that I'm interested in. In fact, every one of you has probably a fork of PostgreSQL on your machine, right? So in principle, you can start your own. And so you're not really controlled. Yes, you may have, you know, consultancy, but you can find an expert here, right, in this room. So open source is clearly one of the answers to this, you know, real threat. It's not a joke anymore. So this is a nice segue to get into FOSSEE. So what is FOSSEE all about? So FOSSEE is basically a project that has been running for about 16 years now, 2009 to now. It's funded by, so governments have changed, the name of the organization funding us has changed. It used to be called MHRD, now it's called Ministry of Education. Okay, so Ministry of Education and MHRD have funded this project. It's not a lot of funding, but it's sustained funding. Somehow we have managed, thanks to the efforts of Professor Kannan, who was kind of leading this effort. But I also have been associated with this since 2009. So we've been spreading the adoption of free and open source software in education. Of course, we're not targeting everybody, but education was that is Ministry of Education, right? So they're looking at, in fact, we are looking specifically at higher education at this point. And so one of the things we do is we do a lot of training through workshops, online courses. There are spoken tutorials, and in fact, there's a, as I said, nice spoken tutorial available for learning basics of PostgreSQL. We also do things like lab migration. So there's a lab running with MATLAB. There will be actually folks from FOSSEE who will help migrate all of those scripts to use some open source equivalent. Usually it's Scilab, so they will migrate that. Then we've taken a project where there are many textbooks. Many textbooks will have examples, and very often these examples will be in MATLAB or something else. But we have trained students across the country, pay them a small honorarium, and they translate these to use open source equivalents. So there are like about 1,000 textbooks that have been translated like this, about 500 to 600 in Scilab, about 500 to 600 in Python. Okay, so there are tons of these books. Then we also do lots of internships. So I think to date we have done about, anyone from FOSSEE here, you can correct me if I'm wrong, around 1,000 interns in the last 4-5 years, right? And the number is only growing. And these interns do open source development of various kinds. They may do some things that are relevant to FOSSEE, but they may also take up general open source tasks. So for example, one of our project managers leads on eSIM. It's called eSIM, which is for electronic circuits, basically, of the whole gamut of things. So there are tools there, and so they both do the development as well as the propagation of, telling people that these tools exist. They are free of cost. You don't have to go to Cadence. You can still do a lot of the work using these open source tools. So there are many. So there are about 13 such verticals for different software packages. I'm running out of time, so I'm not going to spend too much more on this. But some of the interns work on their product, on their thing that they're working on, or some of them contribute back to the greater open source movement. Okay. So that's another. And then there are independent development efforts for things that are equivalents. Like eSIM was created because the project under which we were funded explicitly said that we don't want to use tools like ORCAD. ORCAD is an extremely expensive EDA tool, and eSIM was created to actually replace that. So there are some development efforts. And then of course conferences, events like this, FOSS clubs, a lot of these things we promote. Okay. And again, the idea being, we want people to be aware in a country like India that there is open source software, that you can do 99% of your stuff with open source software. Even those who use MATLAB for research, they don't need MATLAB for teaching. You can use an open source equivalent. So then students can go back and be equipped with these tools so that they can actually do research and contribute to the nation by doing this. So that is the goal of FOSSEE. So this is our small attempt to get to the what the government would like us to say Atmanirbharta, to say digital sovereignty. Okay, so that's what FOSSEE is in here for. So we're very happy to see that there are so many open source enthusiasts here in Postgres, and we hope that you will carry the torch forward. Thank you very much.
Thanks a lot, Professor. So I'll request Hari Kiran from Open Source DB to felicitate. Thanks for your time.
Thank you so much, sir. Thank you so much. And thank you for the opportunity.
It's good to have you, sir. So we'll start with our talks, but before that, I want to also call out, we have the youngest Postgres developer with us. She's Chinmay, Ashutosh Bappar's daughter. So good to have her here as well. So okay, so we'll start with our first talk, which is from Ajit. He's a veteran Postgres, started with EDB, and he'll talk more about searches with Postgres. So over to you, Ajit.
I don't know why I'm nervous. You can see, right? All set. So first of all, thank you very much for having here, have you here. I really appreciate your time, especially on a Saturday, not to spending a time with family and friends and spending time here. And I really appreciate PG Mumbai giving me opportunity to talk here. I'm Ajit Gadge. I work with Enterprise GB as a Director of Solution Architect. And today I'm going to talk about a little bit on a search with Postgres, right? I'm going to talk a little bit on a story side, make a little bit lighter instead of going a lot of technical deep. So some maybe here and there. Don't use a chat GPT. It's okay. So many years back when I started my career long back, I used to wonder why enterprises are storing so much data, logs, messages, transactional data, lot data, right? Processing the data require a lot of hardware, disk, memory, and all this stuff. Eventually, job is job, so I had to go with a job. Eventually, I understand that they like to do search when they want. They like to find, they like to get more information from the data they store, right? And then that time I realized how search is powerful, right? You can hear me, right? How search is powerful. I'm going to talk a little bit on the search side. So today I'm going to tell you a small story about this, right? And don't get bored, but you feel everything is this, I heard this, but please bear with me. All of you definitely use somewhere SQL, right, in your life, maybe in college, maybe in your career. All of the SQL database, including Postgres, have these 4 characters in the story. 4 guys. Update. I'll start with insert. Insert is very serious guy. Building the data, right? Always building the data, serious guy. But it take a lot of your disk IOPS. Very serious guy on this. You want to do everything in a separate stuff. The other guy is the update. Update is, मैं अपना खुद का करूँगा, I want isolation. Keep a lock when you do the update. So again, a serious guy, but very important. And by the way, in this story, all are hero. No villain. There is no versus this versus that. Everyone is hero, right? And then delete. You all scared about delete, right? And especially DBAs. Don't want to use the delete, right? Delete का एक बड़ा भाई भी है. Anyone? हाँ? Truncate. और भी एक बड़ा भाई है. Absolutely, right? Drop database, drop table. Don't want to use that, especially DBA in production. So these are all 3 serious guys. They have their own functionality. They do their own jobs. And there is a lightweight guy, cool, chill, calm, select, right? अपना काम करते रहता है. In most of the time, in most of the application, these all 3 guys versus these guys. When I versus, he's doing a lot. He's a workaholic. If you look at the applications, 60-40, 50-50 kind of split. So if select 50% काम करेगा, these all are 40%. So you can imagine the select importance, right? In fact, most of the applications have a dedicated server for select, read-only server. भाई तू अलग से अपना काम कर, है ना? So every is separate. So you can understand the importance of select. And today in our story, this is a hero. This is a superhero, right? So the goal of this select in his life are 2 things. One is relevancy. I'll talk speed first. One is speed. In today's world, I don't think so you like to wait 1 second of the result. Typically on a search engine like Google, I got this 300 milliseconds, less than 300 milliseconds, good average return. Even 1 second is problem. So speed is really important when you talk about search, any of the search, whether it's SQL based search or any other search. So speed is really important. So you want to achieve that as a goal, right? The other is relevancy. Relevancy doesn't mean that is always correct answer, right? Select fire kiya, 10 row aa gaye, doesn't mean that 10 row is correct. So relevancy is very important. But the challenge with the relevancy is that it's come with the, when you do the search, you like to get top 1, 2, 3 results. You don't want to see the rest of the results most of the time, right? So that's the challenge. You want to get the most important result at the top. So ranking kind of things need in a relevancy. And then there is other thing like noisy word, stop word, and other stuff, right? You have a synonyms, right? You know, Apple, kisne dal diya, and PP here and there. So all of these are the challenges of relevancy, and these two are really important for the your search. Of course, there are some other thing like I want to do the data integration, data leke aaja, I do a lot of the search on these all. Those are the side one. These are the two important challenges, or these are two important goal to, you know, for the select hero, right, to achieve in his life. Now, how Postgres can do that? How Postgres can help select hero to achieve that, right? That's what I'm going to explain more. You can see, right, screen. So there are three options in Postgres. Very simple, plain simple. First is standard search. I'm damn sure everyone use that. How many use standard search? Select where clause. Simple. Legacy hai, everyone use that. Everyone use that. But it's most popular. Even today in AI application, this is the most popular. I'm damn sure on that, and production with AI is still good enough to get there, but select is most popular. Select with the where clause. For example, let's say, and you know all this example, let's say you have a name list and you want to find like Ajit or someone, Manoj, select, right? And you put equal to, even it's work on a numbers, less than, equal to, and all the stuff. Percentile. Select का एक भाई भी है, where clause. It's go with the where clause. Select also have his friend, I would say, B-tree index. Most of the time select goes with the B-tree index, and then you get a good result to achieve your relevancy and performance, and the results which select want to achieve. So typically in a standard search you get this all the data, and the good part with the standard search, it works with most of the types of data except really large text as a data type or blob or those kind of stuff. But most of the time उसको कुछ फर्क नहीं पड़ता, number दे दो, text दे दो, varchar दे दो, work very well and most popular. The other method is full text search, right? Again, it's not really advanced, but I'm sure you guys know. I'm not saying that because you all are intelligent working with the Postgres, but those who might not aware, there is something called a full text search in Postgres. By the way, it is by default. There is an extension. It's come with the core Postgres, right? Where the full text search get used. So you have a mid to small, even to large text-based search, or text. A lot of text are there, not only numbers, but the whole text. You can do the full text search. So if you have a single word, then go with the standard search. But if you have multiple words, many times you have, or maybe stop word like ing or maybe the, a, you use a full text search, very powerful in Postgres, right? And how this suitable applications typically requiring advanced kind of searching, like say for example, let's say you have a column like address instead of name, and you want to search like, you know, Pawai plus something, right? You get the full text search working with that. Now, how the full text search work with the Postgres, right? So, full text search in Postgres do a tokenization. Don't compare this tokenization with your all, I know you are all intelligent, with the LLM model. It's simple tokenization. What it does basically, for example, is you have a statement of, let's say, 10 words, right? And then you have also stop words. It break down the small words, right? Create as a token. What is stored in their index is store basically two things, two numbers. Very simple. One is how many times that word occurs, right, in that whole sentence, and then what position. I'll show the demo on this. Very simple, full text search. And then you can use a stop word in full text search and all the stuff. Full text search का भी एक भाई है, and index, of course, it's called gin, not that gin as an index, right? And it help you to get the most out of the full text search. Now, how this full text search, you know, if I go a little bit on that, do you guys know there is something called as a TF IDF kind of algorithm? Anyone? Anyone? Absolutely. Term frequency, inward document frequency. Now, Postgres full text search is not TF-IDF, but is inspired from that. Why I take that name? Because there is a specialized search databases, and they build that, they contribute that, and that's completely dependent on that. I don't want to take a name, but that's what. But Postgres, even before that, they use inspired from that algorithm and created how to do that TF-IDF kind of mechanism, so that you get the right wording and right full text search kind of. It's really powerful. If you really wanted to do the search kind of application, then maybe the full text search will help you. Full text search, we want to do the full text search boost. I want to do the better full text search. तो Postgres में और एक extension आता है trigonomet or PG_TRGM. What it does basically, it basically, let's say you have a fuzzy word, right? You have a APPLFL, or somebody say Ajit TH in last, or Postgres SS, that it's removed, right? Or even then a little bit advanced, if you implement in a right way, it also do the suggestion of the word. If you know that if you're typing, there is suggestion of word, it does that as well, right? So in top of the full text search, if you want more advanced, more boost, the full text search with the PGTRGM help you in this, right? And the new guy in this whole search method, I would say vector search compared to these two guys, or semantic search in plain simple language. Now, vector search and semantic search is not like finding the exact value, it's nearby, and that's what AI based application required, is nearby, find out its meaning. And nowadays we don't want to search only the words or number, हम लोग को और ज़्यादा करना है ना, so word के behind क्या चल रहा है, meaning and all this stuff, right? That's what these guys do, vector based search, or I would say semantic search. Now where it used, right? AI based application, wherever you're building and you want to get that in a semantic manner or nearby manner and get more out of that, then the semantic search work, and that's what the Postgres is popular. Now how this giving this, right? There is a extension called PG vector, create extension vector, download it, and it's not come with the core, but it's download it and you can enable the PG vector or the vector based search. Postgres support it, this is my information, you can chat, Google it, 16,000 dimension, up to 16,000 dimension. By the way, what is a vector basically? I mean, I'm trying to explain in a plain simple human language. It's a basically, at least in the Postgres, it's a float number. Postgres 4 byte. There is something called half float, 2 byte. Number dega. Who give that vector? The model, LLM model. Postgres don't do that. In a full text search, Postgres do that tokenization. It has a function. In this, Postgres do not do that. You have your own model. I'm sure everyone know about LLM, SLM, and you have a lot of this model. They give this number, right? And depends upon your size of the vectors you can store. So typically, at least my little bit experience with this, 386 to 700 size of vector is good enough for most of the application. But yeah, you have a plenty of the room to increase and decrease. Even the if you have image, I think 700, 800 size is fine. And if you try to imagine what is that vector, बचपन में x, y, z graph देखा रहेगा, right? So that's the same graph, but that is a multi-dimensional, more dimension. So you put the vectors and then it generate those kind of, it's match basically those kind of words and get whatever the meaning you are feeding that. And I told already the suitable thing. Now for this is vector search bit complex. So उसके दो भाई है, एक छोटा भाई एक बड़ा भाई, right? So the small younger brother is IVF flat. That's the index type in Postgres. What IVF flat doing is, imagine that you have a cluster, you have thousands of vectors and it's do the clustering. Same wala एक cluster बना देगा. Let's say 10 cluster. It does that cluster, and when you search, it goes to a nearby vector which is matching, and within that cluster group, it goes deeper and find out the nearby vectors, right? That's a typically IVF flat. While there is another big brother, HNSW. Most of the I see the application use HNSW kind of index. Now HNSW work like in a simple plain language. Maybe I am not sure if it is a correct mechanism, but yeah, it's similar like B tree index, but not from the tree. So it goes to the upper layer and lower layer. So for example, it's a highway, you have a highway, so highway mein milega, and then you go to the smaller roads, then you find the smaller vectors. So like that, it's upper graph and lower graph, and HNSW work like that. And HNSW of course required a lot of memory to store this and then execute that, while IA flat compared to that less memory, and depends upon your use case, you use this kind of mechanism with the Postgres. Let's give fantastic results with that. I just wanted to check my time as well, I want to show them off. So these are typical 3 mechanism of Postgres to search. Okay, let me show very quick demo. Very simple, guys. I am not going very complex, but try to, you can see my screen, right? Oh, why is not coming? Sorry, 1 second. Sorry. When you get this PPT on in presenter mode, this happens. You can see my PGadmin stuff, right? Right. So I'm going to show small demo of all these 3 methods. You may find simple, but I want to keep the simple. So let's go with the standard search. I have a basic data of, let's say I'm storing article, right? I have a something 22 article, if I'm not wrong. Front side bada karu. Let me do that. Where is the option? Yeah, zoom in. This is fine? Perfect. So I have a simple 22 is one kind of articles. You imagine like you have a title, you have a small book block, you have a title and you have body, very simple. Then all about something name about Postgres like performance and all, right? And I give an idea as well. So I have approximately, not approximately, exactly 22 articles, not approximately, right, for this demo. And I'm going to show small, very quick demo to showcase what kind of use case you can build with these 3 kind of options, right? Let's say I like to try to find out a Postgres as a single word. Straightforward, legacy, standard search, right? Single word, standard search, perfect, right? I put the ampersand so that it get everything I'm trying to find out in a title, and it's get very straightforward, something 15 rows. No brainer. I'm sure everyone done this many times in their career, right? Now I want to do a little bit trick, more little bit complex. I want to find out a Postgres and vector, right, in the standard search. No result with standard search, because standard search don't understand and, ampersand, sorry, conjunction word. You don't understand that. But we have this kind of queries, right? And we have this kind of use cases, simple in a SQL. How do you do that? That's what there is something called of zoom in. This fine? अभी तो मेरा स्क्रीन आउट हो जाएगा यार. I'm just showing the output as well. I want to show the output as well. Okay. Okay, let me run some queries and then you tell me, right? By the way, these all scripts and videos are available. I share my GitHub and you can get this all the script. But the Postgres and the vector, right? These are the two conjunction word, and standard search is not able to find out. So what is a simple technique with the Postgres, right? I talk about the full text search, and full text search need to convert this as a token. I told you, right? So Postgres have inbuilt functionality, full text search. This is a 2TS vector. What I'm doing is that title or body combined together and convert it into the tokens. I already done that in my table to save the time. Just simple update command. I'm not going here and there and big programming and all this stuff. Everything in the SQL, right? And then I create an index to make easiness. And again, it's based on gin, I told you, right? On the column which I created. And then let's see. I first show you how that tokenization work, right? I done already. So if you look at this title and body, these are the two cases. Let me show this, right? This is what the tokenization done, right? If you look at this connect, there is some 13 number. Connect is word over here in this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Connection. IN hata diya usne, right? That's what is doing the stop word and all this noisy word. And if you look at this, there is something Postgres word as well. Read, for example, it's come third position as well as 10th position. So it's get the position and it's get the sequence as well, right? How many, sorry, appearance, how many times come. Very simple token, nothing fancy over here. It's stored in the index, it's in the column itself, token. And now let's see how our things work. Let me, I'm just juggling to this screen. Oops, sorry. Always use mouse. One second. This may be not right. One second, guys. I'm sorry. Yeah. Thank you very much. Well, let me continue that. Now, this is basically the query, right, which I'm searching. Again, the same, but this time use a full text search functions. The function is 2TS vector, and then I'm trying to find out the same Postgres and vector, right, and see the results. These are the two rows coming as output. Reason, there is something called as a vector. In the same row, there is something called as a Postgres. Only the two rows out of this 22 rows, right? And and then basically why this is first, why this is second, because it also do the ranking, right? If you look at the ranking over here, right, 0 is less ranking compared to this. The reason is that the vector word is first compared to the other line as well. So it does the ranking as well, and you can do this kind of stuff. Now I told about the vectorized search, and before that, by the way, all of these three search you can combine. So Postgres give you the kind of authority to combine this like a hybrid search, right? So for example, let's say in this query, so I already done, by the way, embedding using V6 model. If you know the sentence transformer, all LLM V6 model, I done that. Very simple sentence transformer, is free, you can use that. And I show the vectors. These are all the vectors float number, right? And you can find this small Java program on my GitHub as well, and you can find very easily, right? And based on this, I'm just combining these two query, right? Hybrid kind of query. One is the upper part. This one is a full text search which I'm storing, PostgreSQL. Sorry, this portion, right? This is the embedding. What I'm doing is I'm not trying to find out the embedding. So this will narrow down your result in the Postgres and vector, and this part will give you the ranking, and I can tune the knob, right? So if you look at this, I'll show example. embedding, kitna nearby hai, right? So for example, let's say these are the two results which we saw, and then I just tune little bit 9, 0.9, that's a distance. I'm giving a L2. By the way, this is a L2 distance over here. I forget to mention. These are the parameters, L2 distance, cosine, which is in a typical vector search, right? And then I increase this, and you can see there are few more rows. The reason is that I increase little bit the nearby search. So embedding will not give you the exact result, but it will help you to get the nearby result, and you can tune that. It's like a knob, right? So this is how you can do the hybrid search as well. Now let me show you very quickly, if I have a time, I guess, right? Let me show you very quickly one small example, and then I'll conclude that I'll not show. Yeah. So this is a basically RAG-based application. You heard all in AI world RAG, right? Retrieval augmented generation. Le lo, banao kind of thing, right? So basically a very simple RAG-based app, small script, nothing application even, right? And same data, same SQL. SQL apna bhai kaam kar raha hai piche, right? So it will ask you the some kind of question answer. I'm connected. Loading some same model. I'm using a re-ranking cross, and I'm using a sentence transformer for the embedding, right? Ask the question like, what is a Postgres AI search? I'll give you the 4 results. Typically, if you look at this, top 4 is the rows, and there is a generation, right? It gives a summarization. How Postgres can you blah 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 and all the stuff, right? Same, let's say, what is how to scale Postgres, right? So it will find another document which is the same and give the generation, and straightforward. So the idea is basically you can build this kind of chatbot using the Postgres, behind the scene Postgres, everything is Postgres. Of course, LLM model you need to use for this kind of application, and you know, this is the architecture, but I don't have right now time the how this works, right? This is how the chatbot works, which I was showing. Everything stored in the Postgres, no need to go out except LLM. In fact, some of the companies, like I know Google has a Vertex, Azure has a Gemini, they provide expose APIs. I work with enterprise, we have a PGDay. Those expose this API to use the LLM model. You can get everything's bundled nowadays with AI application as well. Now let's conclude that. I know I'm taking a lot of time. So conclusion, basically Postgres give you the options to do the search, depends upon your need. I'm not against AI, or of course I am not, but then every solution is not with AI. You know, so time barbad mat karo. The question is, what do you need your application, right? The question is not how you use AI. Everybody nowadays, at least in industry, want to see, hey, how can I use AI in my application? That question is not that. Question, how can I solve the problem? Maybe with AI, without AI, right? So use your options wisely, and so end of the day, our hero select one using this. He achieved this two goal, and end of the day, Postgres won. So thank you very much, guys.
One quick question.
Yeah.
So does the explain plan for full text search look different from that of a standard search, or how does that interact?
Of course, it definitely looks different, because you use the different indexes, use different functionality of functions to do that. So you definitely have an explain plan different than full text search.
Anyone else has any questions?
Anyone, any question? But I am around. I know taking a little bit more time, but anyone, quick, maybe one question, and I'll hand it to next speaker. Yeah. Yes, there are. I mean, at least where I am working, we are building similar kind of application. There are many applications building on using PG vector as a vector database, and then transactional database. Data is coming from here. So yes, the answer is yes. And if you look at the Google search, There are some other vector database as well, but in top 3 you can find Postgres as a PG vector as a AI vector database as well. I'm around, guys. If you have any question, please catch me. I'm happy to answer you.
Thanks a lot, Ajit, for your thought. And Ajit is so passionate about search, he ordered all the lanyard with the alphabet. So I like to request Ashutosh sir to facilitate Ajit. Thank you. So the next talk we have from, I think recently, if you're following Postgres, you might have heard about a lot of acquisitions around Postgres. Some of them were done by some of the leader in analytics like Snowflake, Databricks, all of those. So we have next talk from Kamesh, who is from Snowflake. He'll talk about PG Lake and areas around that. So Kamesh, over to you.
All good? So, is my screen big enough? People from behind? Or you want me to increase the font? Okay, let me do one command and see if we are able to see this. All bigger. I'll take a seat if you don't mind, so that like I don't hide your screen across. Is the font clear enough, or you want me to make it bigger? Bigger? Is it okay? All right. So let me go into, I'm going to start with a little thing. So assume that I have a list of files, a CSV, Parquet, you imagine whatever files we have on S3. Okay. I'm going to show you a typical nightmare if I want to take this data inside Postgres or any kind of database that you want to have. Okay. So, so what basically happens is that, for example, let me see what this data is like. I'm going to read this data. I just downloaded this little file for convenience. And if you see this file, so it has like 1, 2, 3, 4, like around like close to 10 columns or something like that. So when I have to get this data inside, so there are approximately 10 steps that we do. First, obviously download the data. That's what I did. Then see this file to see what columns you have. Create a table, do a schema definition. Then find out data types, cleanse the CSV, and finally load this stuff. So that's what the usual steps, which I typically call this as a nightmare steps, right, to do this. So now what I'm going to show you is like, for example, I'm going to say, I'll show you the commands in a second. Okay, this is running on my local Docker thing. So I'll show you the repos and everything stuff right now. So right now what happened, you saw the same file that I was having there inside my S3. And then I just did this one, like just created a foreign table. You see there is no column definition, there is no schema definition. We just read the Parquet file or CSV file or ORC or JSON, you name whatever file you want, and bought the complete stuff inside. We deduced what schema it's going to have, bought the schema inside, and then listed the files for you as well, right? All the rows. Like technically, if you imagine, I have saved you like kind of minutes together that you spend kind of doing this job just for one simple file, beautiful seconds. But before I go into what made this happen, so let's go back and see what I'm going to share you right now is this, right? So, so this is where we start with stuff, right? So you imagine we saw the easiest way of how we actually did this stuff. But just pause for a second and we go for the traditional way of how we actually do this, right? That's where I'm going to talk about how we use PG Lake to achieve this, right? What are the components that we have to do this, all right? So just to give a quick intro about myself, I'm Kamesh Sampath, lead developer advocate at Snowflake. I've been with the industry for quite some time with AI, cloud, and other stuff, doing a bit of stuff around data right now. You can ask me questions around AI and other stuff, what we do with Postgres, and talking about this. And Postgres is a little close to me because that's the first line of code I ever wrote in my career like 25 years ago. So this create table statement that I wrote on Postgres was my very first thing, so it still stays close to my heart. So that's the, but what I now want to call is like, we saw the easiest way of how do we actually do this stuff. But let's step back and see like what was the actual original way of doing stuff. How many of you agree to me that everything that we do within an enterprise, we always tend to do it very complex? Do you agree with me? It's a complex infrastructure, complex other stuff, or even for the simple thing, right? For example, if you imagine the thing that I did earlier was just importing a table, I want to query the table and find out the data out. Why should I have so much of complexity? It's on to my left side. If you see, that's a complex data lake path that you usually take. I'm not complaining about data lake. Data lake is super. But when I want to query something from my data lake, I have to go through all these steps. Pick up a query engine, configure metadata, set up security, build a pipeline, and by the time I get the data, it will be days, right? If I want something quickly. But right now, what you have done, what you have seen right now is like how we made achieve that so simply using PG Lake on the boring, you always call this a boring good way. I just got into SQL, got into PSQL and just say select star from this table, give me the data. The same data that is residing on your data lake, we are able to get that in with one little extension called as PG Lake. I'll talk more about that in a second. But the whole thing is like why we don't want to take so much of infrastructure, so much of pain for doing something which we can easily do, all right? So what is PG Lake? PG Lake is an open source project from Snowflake. It's another PG Lake, it's another extension, a traditional Postgres extension that is available for you. It's open source as usual. What does it do is like, it kind of like, as I said, like it's 100% open source, its own data. You're going to query the data that is near to you. It also helps you to do with open table format. How many, I think most of you heard about Iceberg and other formats that we have in Apache. It supports Iceberg format as well. No move. You saw that when I was having the list of Parquet file that's still there in my S3, but I was able to query that directly within Snowflake. I mean, sorry, Postgres, right? So which is like make it so easy. There is no even heavy lifting as well. Lastly, with open table format, Iceberg support, we are also bringing that universal compatibility, which means that the same query, the same data that resides within Postgres, I can use any other query engine to kind of go query the data connected to Postgres because it's Iceberg format, right? That's as simple as that, all right? So what I'm going to show you next few moments is that like, we'll see a few of these things, right? We have the data in for me. So what is the advantage of getting this data and using this data? One, upgrading to Iceberg. As I said earlier, using to Iceberg, I can make it to query in multiple data formats, right? Multiple query engines and other stuff, all right? Then we'll see ACID transactions, where we'll delete some rows that is there in my table and see how we can recover that. PG Lake right now doesn't support the complete time travel thing. We're just still implementing that stuff. Watch out for the open source project. That's where you're going to do time travel. And last but not the least, we are also going to make Postgres as your gateway. What I mean by that is that it's not only that we're getting the data inside Postgres using that PG Lake foreign table thing, we're also going to take the data out, like extract some data out from Postgres and save it inside your data lake, which means that you're also going to give that to other engines as well. So these are a few things that you're going to see right now. Let me jump into the demo again. I'll share all the sources of the demo soon, so don't worry about if you miss the thing. The very first thing that we do now is I'm going to convert this one into Iceberg tables. So if you don't know about Iceberg, I have all the links about Iceberg and every other stuff in my README. I'll share that README in a second. I'm going to do this task. Task is nothing, but if you're not aware of task is a simple cookbook of recipes like a make file. So where I can combine multiple commands together just for convenience to save some typing. So I'm just going to say Iceberg. There you come here. After we brought this table back, you see this, I'm kind of dropping this, checking if it's there already exists. Then all I have to do is like just do this. That's all. It's no complex schema again, right? I just say create table. I call this as Penguin's Iceberg just to clarify. And then I'm pointing this out to your all the Parquet files that exist in my S3 bucket or any other storage for that matter, not necessarily S3, it could be Azure, it could be GCS, you name it, wherever you want. And then I'm kind of loaded the data, and it's kind of loaded in 333 rows for me, all right? And now I'm querying the table directly within Snowflake, and you should have, sorry, Postgres again, I'm sorry for mixing the words. And then you see that I kind of also have catalog and other metadata also available to this. What are these metadata about? Okay, that's what next thing I'm going to do. I'm going to say task iceberg list snapshots, right? Every commit to the data that iceberg does, there is a snapshot getting created. That's one of the primary thing how we can go back in time. For example, right now I just created the very first row, loaded all these things. That's the first snapshot. It gives you an ID and it gives you a time when this snapshot was created, all right? So snapshot is very essential when you want to go back in time or query something very specifically. So one of the things that iceberg gives you is that when I kind of query this data out, sorry, fully is okay. It's okay. So one of the things that iceberg does is like with snapshots, for example, when I want to change columns or add columns to a particular data type or schema or something, usually there's a long process for that, right? You have to take the backup of the data, move the data out, add another column, bring the data back in and fill all of the columns null and everything, right? Apache Iceberg solves that problem using column adaptation, right? Which means that it's called a schema evolution, where I can automatically add columns. So every time I do that, there's one snapshot ID that gets created on every commit of your schema change or anything, which means that some application can still use old schema, some application can still use new schema, okay? And you can query that. That's exactly what we are going to do next. As a comment says below, each snapshot is a recoverable point-in-time version of your data, right? If you remember, we had 333 rows. Now what you're going to do is like I'm going to delete some rows from my table, okay? So let's do that. I'm going to say task demo. I'm just going to say modify. What this basically is going to do is like I kind of deleted some records from a table. As a part of modify, I said I had 68 rows of just chin strap species of penguins. I'm kind of deleting that from my thing. You see this delete statement that is below that, and then querying again, and then right now I don't have any chin strap in my table, right? What I meant by that right now is that when I go back and do the iceberg snapshots right now, let's snapshots again. I should have two now. The one original one that we got created, another one which got deleted now, okay? The next thing what you're going to do is like I'm going to do a little time travel. I mean to say like I just say okay, I accidentally deleted that, or some application has erroneously deleted that. I want to go back and recover the data, right? That's what something which you do. That's a very powerful feature of Apache Iceberg, that you can recover the data in any point of time, right? Since it was made. So let's do that again. I'm just going to say task iceberg, okay, not demo, and I say time travel. It's going to execute bunch of queries for you. I'll explain these queries in a second. So if you see this one, I'm kind of go back in my history, okay? From now, like I just did the time travel here. I got two versions of the current state of time travel is only I have two species, Adlai and Gentoo, because Chinstrap is not there because we deleted that some time back. And we saw the previous version which is there in my metadata file. Again, that's where the iceberg kind of performance comes into picture, because it doesn't do a full table scan. It just scans only the metadata, which is all the information is required. Okay. To talk about iceberg itself, that's a separate session. We'll do it later. But the retention period, all these stuff, it's all PG Lake extension configuration that we can do. How long you want to retain the data, how long you want to go back in history, etc., etc. It's still getting matured. I'm stressing that again. You might not have all the iceberg spec available yet, so just watch out for the project. And then what we did right now is that we went back to the history and found out how many Chinstrap thing were there. There's 68 records which we deleted if you remember the last time, right? And then we brought it back here and then we recovered the data. And then now the difference was 68 between then and now. So where would we put it? For just for clarity, I just put that in a different thing. PS equal, let's see, select count of star from, if I remember correctly, I just name the table as penguins time table, where species, did I get the name right? Yes, is equal to chin strap. Okay. So now I got the 68 rows back again. Okay, this is a time travel table, which means that I was able to recover the data back and go. Okay, which means that don't worry if the data is lost. I think that's a powerful capability that we are bringing inside Postgres using PG Lake extension, which means that it's Iceberg native. It also does all of the Iceberg stuff. It's also easy for you to create foreign table, talk to your external CSV Parquet file that is there in your object storage, any object storage for that matter. I was using S3, but it could be anything you want. And lastly, as I said earlier, it is also acts as a gateway. So what I mean by that is, for example, let's go and do that one as well. I'm going to say task demo and then say export. I'm going to export certain data about a particular species and then store it there so that other applications that might need the data can query the object storage and get the data again. I'm going to put it back to the gateway again, I mean the data lake. So I'm just going to say export. If you see here, it's again, it's another command that is added to your thing. So we're saying how many species we have Adley thing, which are going to do this. We're going to do select star from this particular species. And then I'm just targeting say to S3. That's it. So it could be anything, end of the day, right? Then go and store this as this particular Parquet file inside my S3 storage. I think this is again happening transparently for you, because you don't know, like, you don't need to connect, bring the data out. You don't need to have multiple consoles. You're using the same vanilla SQL syntax that you're used to do in Postgres. You're using the same stuff to do this stuff. You don't need to do anything extra. You don't need to learn anything extra. Couple of more SQL commands that you're going to do here. All right. And then let's go and verify if it is there. I'm just going to, if you remember, I just did this task S3 list. So this is going to list me the files that is there. It could also include a lot of Iceberg stuff that we changed here, because everything gets stored there. And you see this one, the Adley penguins thing, it's there in my S3 bucket, which means that I can now connect this to any other storage engine or take it to some other thing and kind of do this stuff. All right. Great. I think we saw most of the stuff that we saw here. See, we just iterate whatever we think we saw here. We just upgraded to Iceberg table. We use ACID transactions, delete, modify, update. Just showed you a delete example. And then we saw about time travel. We went back in time and then did. And the last of it, I did not show you something which is there. Is like you can also go back and do joins between your lake files and then your Postgres tables as well. I think I did not show that to you now, but that could also be done, which I can do joins and transactions and everything between Postgres and your data lake. Everything happened within one little extension called as PG Lake, which does all these heavy lifting. And this is still maturing, ladies and gentlemen, that you can also go back and check out the project. I'll share those repositories for you in a second, so where you can go find out this stuff. In that case, like what happened to this, why this evolution happened from Snowflake, I just want to share this little thing. In Snowflake, if you remember that we acquired this company called as Crunchy Data a year ago, and then that has got merged into this. All this PG Lake thing was coming from Crunchy Data, where they were starting to develop this whole extensions and other stuff, which are kind of technically bringing into Snowflake as well. Watch out for Snowflake Postgres space, where you will also see more things that is coming inside, where your analytical features are also going to be there. The OLAP and OLTP bridge is going to be crunched now. I think if you say the Crunchy Data way, we're going to crunch this out. It's super easy for you to get this one. I'll show you those spaces as well. But before that, if you want to try all these demo by yourself, and this is the, you can scan this QR code where I have the demo repo, and all you have to do is like just git clone the repo, do the task setup all, which basically builds a Docker image for PG Lake extension locally, and then start Postgres for you. And then just done demo all, which will show you all the commands that I run. You can also done all individual demo commands like how I did. It's completely documented on the README of the repository. And if you like that, just give a like for the demo. You can do everything. And if you want to check with me again, you can just connect me on LinkedIn, GitHub, anywhere. I'm also outside for a few more hours. You can just ask any questions that you might have. Before I sign up, I just also wanted to say something where you can also find this repository. So the PG Lake repository is right there on GitHub. If you go to Snowflake Labs, let me see if I can bring this down and zoom it properly. It's GitHub Snowflake Labs PG Lake. This is where you find it out. The demo repo also has a link for it. You can go there. If you want to try Snowflake Postgres, I'll tell you it's way easy. For example, let me blow this up a little. This is my Snowflake console. If you can go to Postgres and then click on Postgres here. Sorry, I'm hiding this side. And then it gives you an option to create a Postgres instance directly inside the cloud. What you can also do is like, let me go here, let me sit down so that I don't hide. So, and then all you have to do is like, I need to change my role. I need to be an account admin to basically create this. I can click on create, give a name to an instance. You can go from 1 core 4 GB memory to 96 core 384 GB memory for Postgres. I don't think so you need so much for Postgres, okay, but you can go up to that. And also any number of storage you can go up to. This is the maximum limit for storage as well, 65,000 GB. And you also have 16, 17 and 18 being supported, because that's a time where you can also get PG Lake extensions working for you. And you can also have network security already, and you can also turn on replication with eye availability here as well. So all these things come out of the box just by doing this one. The another important thing about Postgres, Snowflake Postgres, is that it's a standard open source one, package inside after the Conchita thing. So we also have the common extensions. For example, Ajit was talking about PG Vector, PGTRM, and all these things are already loaded for you. You just need to say, just create an extension and do this. PG Lake is also going to get in there, which means that all your lake capabilities is also going to come there, where you're also going to bridge, as I said, bridging the gap between OLTP and OLAP. Okay. How do I get to this? Very simple. Just go to signup.snowflake.com. It's 30 days. You get $400 credits. No credit card required. Sign up there. The moment you sign up there, you'll see the Postgres thing right is here, like as you saw here. On the left side, if you go on navigation, you can manage Postgres here. Go to sign up there and then sign this up. Okay. I think that's all I have. I will leave with the link here, and still if people want to grab, or if there are any questions, I can take any questions, or you can also catch me outside for any other questions. There's one question. Yeah. One.
So like when you're loading that particular files which are stored in the S3 buckets, Leo, Packet and CSV, those are in structured data, right? So whenever you're loading that file, will it occupy the space only from the S3 bucket, or your PostgreSDB will also occupy that space?
See, the Postgres is going to create, see the idea of S3 bucket, the S3 tables, the Parquet files or data files will still reside in object storage.
Okay.
That's the iceberg format specification. It will not bring anything inside your database, right? The database create table or create schema is just going to occupy whatever the little space that is required to create the table and other stuff. It's not going to bring entire data inside and store that within your Postgres thing.
Okay, okay, fine. And if I have my files in like PDF and Word files are there available in the S3 bucket,
Can you be a bit clear? I'm not able to hear you well.
Okay, if I have my PDFs and documents in S3 bucket, can I load that particular files in my PostgreSQL?
See, if you have PDFs and documents, that's a different story altogether. That is kind of like you want to convert that into AI format using PG Vector, so which you can definitely do that.
Okay.
Which is possible, but that is not the job of PG Lake extension. PG Lake is to bring your data lake into Postgres. What you're talking about is your vectorization of all your documents and other stuff, which is a different use case altogether. Okay. But you can still bring it. Should not be a problem.
Okay, fine.
Any other questions?
So when you were showing, I think it's a foreign data wrapper, the FDW. Okay, so I have a question, like for the CSV and the S3, like if you do some kind of select, okay, so like are you going to fetch all of the data and then like, you know, like find from each of the rows, or
Okay.
is like for the Snowflake, you can send a query from Postgres, but for the dumb data like CSV or the S3, how are you going to like handle that?
See, I'll tell you how it basically, I think the whole backing behind this is done using Apache Iceberg spec, open table format. Okay. What basically will happen, I'm using a local simulator for S3. So if you see this one, there's a PG Lake thing at the repository that's been created here. So this is again, this is how it actually will happen as well. So any table, this Postgres thing, and then there's a public, your namespace, and then Penguin Iceberg, if you remember, that's a table which we created. And this is the manifest of all these things. There is two folders which usually get created. Like this is what I can answer to your question. Your data doesn't come here. The metadata file serves as your source of truth, meaning to say with Iceberg specification, the data doesn't go into the actual data. The metadata files has all the information, including the partition which you there, the snapshot, current snapshot ID, what is a few other statistics like usually have, what's the maximum, for example, if I store an employee table, what's the max salary, min salary, which department he has. It means all these statistics so that your query goes super fast on the metadata and come back, right? which means that when you're kind of doing all the things that you're asking right now, it's going to go only to this. Nothing is going to come and store in your Postgres. Is that the question? Did I answer your question?
So like you send a query to the iceberg table, and then you get the data. It gets processed there at the iceberg, and then you get the result to your
Yes.
Postgres. Ah, okay.
There is a, see if you can, for example, behind the scenes, there is a REST API that basically runs. So Iceberg REST a catalog, or you can use Iceberg Hive or like Iceberg Hadoop, and all these extensions are available. But the easiest way, if you heard about this particular project, so we have, I think Snowflake also contributed this to open source, which is now in incubating in Apache. Apache Polaris is a REST API, REST catalog for your Iceberg extensions. So which means that Iceberg table, I mean format specification. So all the things that PG Lake right now does, the Iceberg spec is there. It's going, the API spec is there. It's going to ask the API spec how to implement it, and that's just getting implemented. Just like an old world, I think, to be honest with you, the data world is catching up with the app world pretty later, right? Using API based kind of thing. I think Apache Polaris is one implementation using REST catalog. The same all queries and everything will go to Iceberg on REST catalog. Nothing gets stored on your thing. That's the reason when you saw the create table commands on Postgres, it was empty. There was no columns, nothing there. Like it was just a marker thing that is resides there. And whenever the query comes, there is underlying layer which basically touches. Right now, what we have in PG Lake, we use DuckDB under the name. So which means the DuckDB Iceberg extension is getting used, which uses, I mean, the implementation of all the Iceberg specs. So it's again a REST API call to go there and then do the stuff. All right. I think I'm time. Yeah, one.
So is it different than the materialized view, which we use in PG Lake versus materialized view?
I think
Because you're saying that API has been used.
I think I can call this pretty much closer, but actually I don't do an apple to apple comparison because those use cases are too different for two of those things. Okay, so in this case, it's just a kind of like, as I said earlier, your PG Lake is a gateway to the data that is residing outside of Postgres. That's the only thing if you have to keep it simple in mind, right? And now on top of this, you can create materialized view, normal views, any views you want to extract the data. But it's just a connection that is happening, so that like you don't need to bring the data. Traditionally, as I said earlier when I started it, you have to copy, download, cleanse, do all of the stuff before you actually load the data, and the CSV has to reside beside the thing, right, for you to load the data. You don't need to do that anymore. Just point it to the storage, everything comes inside. Okay. Sure. Yeah, I think any other questions if we have, probably I'm outside, happy to answer those questions. Yeah, sorry about that. And thank you so much for PG Mumbai for having me in, and it was lovely talking to you all. And if it's okay with you all, probably I just take a quick snap just for my own stuff. First time here in Mumbai, I think I
PG Mumbai.
Okay. Thank you so much. Thanks all.
Thanks a lot, Thomas. I think this is something which all are looking forward to, and even I'll have to do it. So thanks for doing that. And
Good. Any questions? Obviously, you can ping me on LinkedIn, GitHub, anywhere, Twitter, wherever you see me. Like happy to answer those questions.
Sure, thanks a lot. We'll request Himanshu to felicitate Thomas. Himanshu from KPMG. Thank you.
Thank you so much.
So the next talk we have from Jeevan. I think one of the things that as and when you get more senior, you want to understand what's happening beneath a query. And it's very easy to make out of it if you know some of the internal parts. So Jeevan will cover that part. Over to you, Jeevan.
So good afternoon, everyone. I would first start with thanking PG Mumbai for giving me this opportunity.
I am with Enterprise DB since 2008. Uh, directly passed out from very well from this institute. I remember the exact date when I appeared here. Last date is on 8 August 2008 for my convocation here in IIT Bombay, and it's 17 plus years. So it's very something. Lot of changes happened in IIT Bombay, but I'm really happy to come over here again, and very well thankful for PG Mumbai for giving me this opportunity. Well, so I'm working for Enterprise DB, which is a Postgres-based company. So obviously, I am looking at Postgres since 8.3, I believe, and I'm a pure developer, right? So I know the internals, but many a times when support people gets a query about something happened and my database or my queries have started running slow, right? And sometimes they might not understand what exactly happening behind the screen, and they come back to the developers asking those questions, can you look at what exactly happening? And our very first question to them is, do we have an explain plan? Okay. The Postgres has the explain command, which gives a plan. The plan is nothing but the step by step how the executor is actually executing your query, what kind of nodes it has, how it end up choosing that particular plan. But many of the developers, even DBAs or support people are struggle to understand that explain plan. So this is my just one way of giving that back to community, or I want people to understand that how to read that explain plan. So I'm not going in much complex plans here in this talk, but I will rather believing on having some basics clears. So once we have basic clears, then I'm sure that you all engineers can able to deduce the complex parts as well. Right? So just moving further, I'm just skipping the agenda because it's already part of the talk anyway. So what is optimizer, right? See, every database engine has their planner and optimizer, right? And believe me, the planner is very much smart and they think all the aspects of your database, looking at your indexes, looking at your joint strategies, and many things. So they create lot many paths behind the screen, right? So obviously at the some time you need to give up some paths and sometimes you need to accept those paths, right? So how that particular happens, right? So planner gives a matrix to each and every path, and at the end it chooses the cheapest total path. Obviously cheapest in the sense because planners thinks that this is the fastest one to execute your query, right? So obviously I have this Google map that when you want to go somewhere and you put on your map, it gives lot of different paths, right? And then highlighted one is the cheapest one according to their algorithms. So exactly behind the screen this happens at the database engine as well, right? But how those paths are generated, how got selected, how to read those paths, that I will try to explain in this talk. Obviously there are many paths, but there is one plan. The cheapest path is converted to the plan. So plan is what handed over to the executor, and executor simply runs those particular instructions to get from a start of the query to the end of the query, right? So in paths or in plan, what you will see some costs. What that cost means, for executing something, right? You need to give some metrics, right? For example, let's say I want to read one tuple from a disk, right? Then obviously I need something, means so how much time or how much not with how much metric you can give to that particular event, right? For example, you want to execute a where clause, right? You want to execute every condition for each and every row, right? So we give a matrix to them. So we call those metrics, and there are a lot of constraints defined in the Postgres system that you can very well modify. You can some are GUC oriented, some are you can simply modify using the catalog table update straight away. but few are listed at CPU tuple cost, CPU operator cost. There are lot many costs, and those remain same for all the parts. So all the parts are evaluated using the same constants. So at least we are fair enough, right? And then obviously while choosing a path or plan, we need to know how many rows are there. Then we need to have some estimated row. Then we will get some actual rows at the time when you execute the query, right? Then there is a width of particular tuple. That's also very important to know as a planner, because that width is required to calculate the memory requirement for that particular node to execute. For example, if you are going in a hash joins, right? So for hash, how much memory is required, that needs to be calculated, and that width is very well used in that. If you are not enough memory, then obviously no one go with hash join because you don't have memory, right? And then this other details also in the explain plan, like actual timings or execution time, etc. So this explain plan can be used for various all the DML queries like select, insert, update. Even it can be used for create table as and various statements. So I am just going on a SQL based. So I will give example, and through example I will try to explain how we can actually make sense of that query plan. So before going back, this is the setup that we have. So I have created two tables, my tab 1, my tab 2. One has 1,000,000 rows, second has hardly 1,000 rows, and I have analyzed the table. So analyzing a table are very important in this planning optimization, because when you analyze a table, all the statistics are built and stored in a table, so that when you execute a query, the planner reads those statistics and then accordingly builds a path, right? So this is a simple query, and I have that select as I analyze as build a statistics. So I have put rel pages and rel tuples. So indirectly for my table 1, stored on a disk, it has total 5,406 pages. Each page is around 8K in a rows case, and as I inserted 1,000,000 rows, that's the number. Similarly for second row, it's 5 and 1,000. Okay, just keep those number in top of your mind, because the costing will be depending on those number. And there are some planner statistics or constants like CPU tuple cost, which is defined as 0.01. You can tweak it, but these are the default values. And sequential page cost, if you want to explain plan, add a explain keyword at the start of the statement, you will get it. But then there are some various options that you wanted to see in an explain plan. You can put those in a parenthesis. There are various options. I have listed at all of those at the end. And there is an old syntax as well, which is text, analyze and verbose only. So you can just put back to back and false statement. But if you have multiple options, the recent statement is put everything in a comma separated list in a parenthesis. So let's start with a simple select. Okay, select star from my tab 1, and I put explain. So I end up getting this row, right? Then how to read that? So when SQL scan is, it says a sequential scan. So anyway, when we read anything from a database table, then you need to scan those tables, right? So there are different scans. So that sequential scan means you are reading each and every row from first row to the end row, and there are the index scans, there are bitmap scans, various scans as well. So this particular query is using a sequential scan, and the cost, there are two costs, 0, 0 and then another number. So 0 is the startup cost and the second is the total cost. So we are more worried about the total cost, because that defines how much time it's going to take. So this cost is not directly related to timing. These are the metrics derived from the constant that we have. So the simple calculation I said, since we have 1,000,000 rows and we have around 5,406 rel pages, and as I shown, the sequential page cost is 1 and the CPU tuple cost is 0.0101. So if you simply calculate that 5401 into 1 plus 1,000,000 tuple into 0.01, that's exactly gives that 15,406. That is what your total cost is. So that is how it calculated, right? And you can see the number of rows also shown in that sequential scan. And since I have only 3 columns in a table, all 3 are integers, so it's 4 into 3 is 12. Okay, that's something, sorry. Okay, so just tweak it little bit. Okay, now just add a where clause to the query. So I have added where A less than 800,000, and my query still a sequential scan, but now you see the cost is slightly more. Quite obvious because now the where clause is added. So, obviously, I need to filter a row from those. So, I have 1 million rows, but I have condition that I want rows which is less than 800 obviously. So, there is one more cost also added of a where clause, and there is one constant called CPU operator cost which is defined as 0.025. So, this particular CPU operator cost has to be run on each and every row of a table, right. So, there are 1 million rows. So, if you multiply 1 million by 0.025, that adds 2500, and obviously that earlier one was 15406, now it stands to be 17906, fair enough, right. So, are you making sense of those, what exactly happening behind the scene? Well, okay. So, this is the same plan, and now you can see the filter is also showing which actually what actually happening in a executor level. So, now let us go one step ahead, try to add an index. So, I have created an index now on my tab 1 on column A, and now I have run exactly the same query, there is no change in the query at all, right. But I have index now. So, what my understanding is, I have created index. So, index is faster. So, I will see the index plan, right, but no, it still will see the sequential scan, right. Then the exact same plan is there even though I have an index, right. Quite surprised, right. So, even it's obviously surprised. So, let us see explain analyze first, and then we will come back to exact same query again. Okay. So, what explain analyze does? So, explain obviously its explain is already part of that, but the analyze part is this, is actually executes a query. It actually execute, but it does not show the output of query. So, it discard the output, but in the background it actually executed the query. So, here we need to be very careful about using explain analyze, especially when you are running that on a delete or those command, because it will show the explain plan, but behind the scene actually executed, your data will get lost. So, be careful about those. There are various other tricks to avoid that. I can explain that in a break or something. But anyway, this explain analyze in actually executing a query behind the scene, it is now more details about the what happened behind the scene, right. So, you can see the actual time, you can see actual rows details. It also shows the actual planning and execution time at the end, and since we are executing query, it allows few more options to be used with the explain, kind like buffers, how many buffers are used, is there any walls affected by this query or not. Okay. So, again, so let us back to exactly the same query, right. Now, I use the explain analyze. In recent V18, the buffers is on. So, I explicitly put buffer off. So, I do not see a buffer row, but we will see that buffer later. So, it shows rows removed by filter, that is 2001 because it is less than 800,000. And if you see the actual rows is exactly matching with the output, and if you see the execution time now, it is around 170 millisecond. This is with a sequential scan, right, default one. I have an index, but it still went to a sequential scan. So, Postgres has many planner tweaks GUCs inbuilt, like this enable sequential scan. So, I now disable that because I want to index to hit, right. I have created an index, but it is not hitting. So, it is always going to sequential scan. So, I disable that. So, I have disabled that and I run exactly the same query. Now, since the sequential scan is disabled, then I need to fall back to the index scan. So, that is what we are seeing here in a explain plan. Is now the plan changed from sequential scan to the index scan, and which index it is using. So, there is information also there using followed by the index. And now, obviously, the total cost of the query is also increased to somewhere in 27K. It is quite obvious because index is another kind of a relation in the system that you also need to read it. Obviously, that cost also adds. And obviously, if you see the execution time here now, it is around 280 plus millisecond, which is costlier than the 170, right. And that is why exactly the planner, even though we have an index, is went on a sequential scan, right. But believe me, the planner did consider this plan but discarded it. Okay, so I just again enabled the sequential scan so that my default plan will be back to a sequential scan. But here I tweaked my where condition is now A less than 800,000, I just put A greater than 800,000, right. Now this condition is actually now change the default selection of sequential scan to the index scan now, right. So why is very much clear, right, because the number of rows that I need to fetch from a actual table is now reduced from 800,000 to just 200,000, right. So obviously those fetch time is now drastically reduced, right. Earlier it was 800,000, now it's 200,000. So obviously the cost is execution time is also reduced, cost is also reduced. And here now I keep the buffers on by default. So you can see the shared heat are also is showing how much memory in memory used by this particular query. So in nutshell, what I want to say here, adding an index is not something that always helps you to speed up your query. So sometimes customers come that I have index, but still the index is not used. So you need to see all these parameters, what exactly actually happening behind the screen. So it always depends on how your data set is. Is your where clause is actually covering all the indexes to actually making use of those indexes or not? So do we need another index? Are your index actually really useful that you can deduce from all those stuff? There is one more on index. Now I have just used a particular column from a table. So instead of select star, I have just used select A from a table, and I have the condition that A greater than 800. So by default this goes to index scan, but now it's actually using a index only scan, right. You can see the index only scan highlighted because those are different scans behind the screen as all that optimizer creates, right. So what index only scan says, ki the data that is required to output is already part of an index. So ideally, I don't want to read the actual data pages or heap relation for this particular query. I can only output the straight away whatever in my index, because that is what you actually asked, right. Earlier it's star, so actually I wanted to output A, B, C 3 columns and my index has only A. So I need to read the actual relation, but here I don't need that, right. So that particular faction change to index scan to the index only scan. So you can always say that if when you are selecting particular columns of a relation, so make sure, and that's a very highly used column, then make sure you have that particular index on your table, so that if you are only using or selecting that column, you are always using index only scan. It's very, very cheap because you are not actually reading a heap table. I hope these basics are very good, because now onwards I am not going to go into how that cost are actually calculating. Rather, I just showing you in those particular conditions what nodes you will see in a explain plan. So when you see the explain plan, you just understand, yes, there is a grouping happening, yes, there is a parallelism happening, there is a join happening. You can will quickly reduce those up. Okay, so like in previous, the available planner options that you can tweak here is enable sequential scan, like I did that. Similarly, enable index scan, enable index only scan, or enable bitmap scan, that you can tweak and you can play around to see what exactly good for your data set. Okay, so I have another example for the joins. So if you remember, I have two tables, my tab 1, my tab 2. My tab 1 having 1 million rows, where my tab 2 has only 1000 rows. So this is simple join, school level join you can say. Select A and X from my table, left join with my table 2 on A from T1 equal to X from T2. Very straightforward query. So this particular query ends up with giving this kind of plan. So what this plan says, as you said left join, so obviously the left join has to be there in somewhere in your query, that's exactly the same. But it says hash left join, right. When you see hash, that indirectly says the joining algorithm that is used behind the screen is a hash. And as I say, planner consider lot many paths behind the scene. So this particular query at the optimizer level have considered hash join. I'm sure it consider merge join, even consider nested loop joins. But all those joins, this hash join wins. So that's why here. Right? And we are doing a joining, right? So obviously joining on a two different set of tables. So you will see at least two scans of those two tables below dash join. That has to be there. If you don't see that, there is something wrong with that particular plan. So here obviously you see sequential scan on my table 1, and then you have a sequential scan on my table T2, which is actually hashed because it's a hash join. It actually has a table 2 and various details that we can see now, that is use buckets 1004, and the memory usage is also shows with because of those analyze. You can see those particular details. Second query I have tried to get to the anti-joint, so I have used the subquery. So, it's nothing but subquery. So, I am selecting from my table where A in a different query. So, that different query is part of subquery. So, that because of subquery it is turns out to a semi-join, but now it is used a merge join. Right? It might have checked for the hash join, the hash join might not want, and it's end up with a merge join. So, everybody might be knowing the merge sort, right? So, merge sort is always, it's kind of dividing your data set to the smallest one, then sorting the smallest one, and then doing a merge sort algorithm, right? So, exactly same algorithm used here, and obviously for merge join we need always the sorted result. So, that is why one scan is using index scan. So, index scan is always sorted. So, you do not have to sort explicitly, but if you use sequential scan, then you need to sort. So, you need see a sort node sitting behind your scan and the join. So, in a short join summary, so when there is a merge join normally happens for the large data set and is usually faster for those. Hash joins are mostly you will see when there is a equality condition you see in a join, and mostly it kicked in when there is a one table is smaller and another is larger. Smaller table can be easily hashed because obviously hash is a in memory. So, always that has to be a small table. So, if you see those particular two conditions, you see a hash table, and if you are not seeing, then you need to drill down why exactly happening. The nested loop join, obviously it's a traditional R programming for I for j, two loops n square algorithm. So, it's always list, but when you just cross joint, there is no other option than using a nested loop join, right. So, we use that, and there are many joins type, we can see those in a statistics of explain, and obviously the parameters that to tweak has enable hash join, enable merge join, enable nested loop join, you can see those. I am already running out of time, I know that. So, there is a sort. So, sorting we see order by B, that is what the sort we also ask. So, order by clause is used for sorting. So, when we have order by clause, you will see sort node obviously in your explain plan, and then you see the sort method as well. It's use the, since the table is big, it's use the external merge sort. So, external merge sort in the sense the data is falling onto the disk. So, I enable the buffers. Now, the buffers showing that temp, read and return. So, those are the kilobytes actually return and read from a disk because you do not have enough memory, right. So, this is what is showing. So, I simply tweaked some parameter, and I just set the work memory to now 16 MB. The default work memory is 4 MB, but now I changed to 16 MB, and my sort is the same query is now changed from a external merge sort to a quick sort. Why is because since increases memory, I have enough memory to keep my data in memory, and then I can do the quick sort. The earlier, since I do not have enough memory, and I need to fall back on a disk, and that is why I went to the external merge sort. So, you need to see if sometimes you see external disk which is very costly and very slow. So, try to tweak this parameter so that much of the possibilities to get into the in memory. Obviously, if there are memory constraint, then you can't help, but try to tweak those parameters. Then grouping, obviously group by is also for a lot of used part of the query, group by having cost. So, when you have a subgroup by, we will see the aggregate node into your explain plan. So you can see hash aggregate if the hashing is used behind the scene, or you can see a group aggregate as well if there is no hashing techniques used inside. And like filters, here the filter is nothing but a having clause that you have. And obviously it's I use the memory option of explain, which gives the planning time memory at the summary level. I don't have anything into that. Again, the parameter to look at it, enable hash join, enable hash x, sorry. Okay, and I have just wanted to add parallelism, but I thought better I'll put with the grouping. So grouping, you will always get hash aggregate or group aggregate, but whenever you issue parallelism or when there is a parallel query running for this query, we always see a gather sitting into the explain plan. So gather is a node where all the parallel workers that parallelism has forked are combined together. So that is combination is happening at the gather node. And you can even see how many various fork had been done to do that particular execution that is given by the workers plan. So here I have used only 2, that's for setting, but you can see as per 4, 8 depending on how much CPU you have. Right? But obviously, if you have less CPU you put, obviously that contention will be possible. And since this is the hashing, and hashing done on a different parts of the query, the aggregation is done as a partial aggregate. Those are not fully aggregate. So you will see those partial count star or partial sum, and at the upper of gather, those are finalized to a final aggregates. So if you see partial words somewhere in partial hash aggregate, you believe that the aggregation is done in a 2 phase. If you should gather worker plans, you obviously there is some parallelism involved in that particular query. So if there is a problem with some parallelism, then try to switch off the parallelism and see how your query behaves, and you can just increase the workers if that demands the system. Okay. Okay, this is just a summary. Pardon me?
Set up some parameter for that one, parallelism.
That is match parallel worker.
Parallelism is already part. Okay, parallelism is already part of a system. So there is a system parameters. See, by default on, right? So I haven't enabled anything. Since my data set is too high, obviously scanning that entire is very costlier than running in parallel. Right? So it's part of a system, but you can tweak those parameters. Obviously, when parallelism kicks in, the parallel setup cost also adds, right? Because we need to fork those many particular workers at the time, and then we need to gather those, and there's do a lot of searching, right? So depending on the data sets, always kicks in or rejects it. Okay, I have done the parallelism. In partitioning, you will see some when there's a partition involved. If a table is partitioned and partitioning involved, you should see a append node in your explain plan. So there is append node, like I said, gather merge or hash aggregate, like you will see append in a query. So if you see append, then there is a partitioning going on in a query, right? And yeah, so already done. So if you are reading some remote database using FDWs, you will always see a foreign scan node in your explain out. So if you are reading a foreign table and if you don't see foreign scan, then obviously something went wrong, right? So you can check on those as well. Like I said, I have used many of the explain options in various queries, but these are the different one that I haven't covered. So there are generic plan, you can pick it, selection if you want wall data should be displayed or not in explain plan, or summary you can keep on off. And there is a format also to how output displays. All the queries that we have seen is all a plain text output, but you can say JSON or XML which look like this, which I can use to your XML reader or JSON reader as well. These are the various references. I have given the same talk in PGConf India in Feb 2019 and last year in PGDay Pune as well. But even I'm a developer, I know the Postgres documentation is very well written. So if you are a newer DBA, go to Postgres documentation, they are very helpful. If you are a developer, there are a lot of readmes in the code. You can read those. That will again give you what exactly happening at the code level. But I kindly request always use the documentation. They are very well written. Yeah, that's it for me. And sorry, I took slightly more time because earlier talk I actually was 45 minutes, so I slightly reduced to 30 minutes. But yeah, thanks PGDay Mumbai again and IIT Bombay also. Hope
Any questions, anyone?
My question is around the generic plans. So if someone's using a prepared statement, let's say do the one query you were talking about initially, it selects star from where some value a greater than, and then you have a question mark. Does the plan include that at what point it's need to switch from a sequential scan to start using an index, or will it just have one of the two and then you just pay the penalty of
so
using?
there is one GUC which moves from generic to custom plan.
Right.
So you can set that particular value when you want to switch it. And there is a even explain out also there is one generic plan parameter also. If you turn it on, it actually instead of putting a constant value, it puts a $1 sign and creates a plan accordingly. So you can see with those plans.
Okay, but the plan that the prepared statement will eventually create will not dynamically switch between the two. It will be one generic plan that just runs for everything.
It will. Uh, it changes sometimes because initially it starts with a generic plan, and sometimes it finds that the generic plan is not so good, so it's switch back to the custom plan. So that does happen, and sometimes it goes in a negative way as well. So that time you need to see what exactly those parameters as well, and then tweak accordingly, or you just simply disable it. Then you see always time a generic plan, or you always the custom plan is better. Then you can just tweak that parameter to always use a custom plan. But
okay.
it shifts, and that shifts it might go in a both way, positive and negative, but it shifts.
Thank you so much. Excellent talk.
Thanks.
My question is that is it now automated one? I mean, nowadays, most of the things are got automated, right? I don't need to do explain and everything. It should get, directly get stored in somewhere where a DBA can, just do and see what is the long running query on my database, what is the cost associated. It is, should get captured and it should start reporting me. Is it
Definitely
possible, or I mean,
Yeah,
is it already
definitely. There are a lot of AI tools actually built on top of explain plan, right? Which gives you those details in a human readable form.
So why I'm asking this question now means this is a generic question I'm putting in front of everybody. Being an open source community, I would like to see that it get embedded, emerge into the latest open source versions coming. Because now mostly, they are putting it as an enterprise, solutions in observability platform or kind of thing. But if it start coming as a PG underscore, something, explain.
Answer this question. So it's something which is open source. It's called PG Watch.
PG Watch. Yeah, I
It's
heard.
fully open source.
Yeah. So PG Watch is one of the things, but because now this is must to understand to the DBA and developer. At the same time, it's an ease for everybody because whenever the problems are there, when high concurrency or velocity is there, and traditionally we saw that kind of problem, then we have to go into the deep and understand. So if it starts giving very do's and don'ts, best practices get embedded into some solutionized kind of thing and reporting it directly, it will make the life of all DBAs
Yeah, I do agree, right? But putting everything in core is always comes with a maintenance risk and all those stuff, and that's why these extensions are there where people can contribute, and whenever they want, they can install that extension and use it. So that's why now Postgres is more leaning towards having extensions because that gives us flexibility to turning on and off. If you put in a server, then every minor change if you do in a server code, we need to make sure that this also works exactly as the previous one, right? So extension owners might take that responsibility rather than core now. Yeah, but yeah, and I said already we have that extension which is open source, so people can use those.
Thanks a lot, Jeevan. And I missed one part. Jeevan is an IIT Bombay alumni, so I think it would be great to have you back here. I'd like to call Madhulika ma'am from FOSI to felicitate Jeevan sir.
Thank you so much for the talk.
Thank you.
And you are alumni from which department?
CSC.
CSC. Great to have you here back.
Yeah.
So we have one more talk. Okay, I just want to see the faces of people after hearing that. So I have one last joke and then we'll break for lunch. So we'll have break till 2:15. We'll back again. So one day my wife was back. So I wanted to understand what happened. So I said, explain. She got more mad. So I did explain, analyze, buffer. So, okay, anyway, so yeah, break for lunch. We'll meet again at 12 to 15. Okay, thank you. Lunch is outside, yeah. And please, I'll request don't bring any of the lunch plate inside the hall. So, yeah. Thank you. So hope you all had a good lunch. We'll be starting our session in a minute. It will be by Drishti. She will talk more about how to use AI directly from Postgres using some extension for real-time prediction. So we can start in a minute, okay? Yeah.
We're just waiting for folks outside to come in and then we'll start in a minute. We good to start? Awesome. Hi everyone, I'm Drishti Jain and I'm going to be talking about real-time predictions with Postgres and Python. All of us are in the era wherein we need to make use of all kind of real data that we have, all kind of real-time data. So what is the best way wherein you can include your ML models, you can include any kind of real-time predictions right in your database queries. How do you do that from start to end with an example is what we're going to have in the talk today. A quick introduction about me. I'm a software developer and into machine learning. I'm based out in San Jose. I was flying to India during this time and I was like, why not share the knowledge with the community out here? Otherwise, in India, I'm from Pune, so this is like close to home as well. I'm a published technical book author. If you scan the QR code, you'll go to my Twitter/X. You'll find a lot of things there as well. I'm a social entrepreneur and international tech speaker. So I have been able to share my knowledge across the globe for the past 5-6 years across different domains, more specifically towards machine learning. So a lot of Python, Django, also into JavaScript and PHP. And I'm a career coach as well. So I have something called Skill Up with Drishti, wherein I help folks who are looking to upskill, who are looking to transition to tech careers, who are looking to grow their tech career trajectories as well. So let's get started. Why exactly do we need real-time predictions? Can't we just use data and create predictions and just use the results out of it? No, right? Imagine working or having results from a model which is based on stale data. On real time, a lot of things can change very, very quickly. And that is wherein it is important that we talk about real-time predictions. If you look at the very first point is improved user experience. With improved user experience, you will be able to create predictions which are based on real-time data. You want the user experience to be utmost so that once they're into your application, you give them everything in one way in a single screen. You don't want your user to keep moving between screens or to keep fidgeting between different applications and leave your application. You need instant decision making and it also creates a very high competitive advantage. If you or your application is able to give real-time predictions, people are naturally going to be more inclined towards using your application over your competitors. And it is very cost effective in the sense of when you're giving real-time predictions, you'll be able to make better revenue out of it. So it is cost effective. When you have a higher revenue, it is more cost effective. So from that point, instead of just relying on stale data or even a day old data for that matter, if you have cache data for the past day and you're creating predictions based on that, today some important news might come up which would change completely. Say you have a sales report meeting or your earnings today and all the predictions you're doing are based till yesterday. So your real-time data is not incorporated into the actual predictions that you're making, and that is going to put you behind. People would not really in future rely or look at your application to be a source of truth. You always want your application results to be the source of truth, and the user does not really have to go ahead and kind of recheck the work that your application is producing. With Postgres, it is a robust relational database. There's a high extensibility with procedural languages, and there's built-in support for JSON and other data types. This is very, very important, which helps enable machine learning or model building right inside of Postgres, because you're able to incorporate data formats. You don't really have to convert a lot of that data into some Postgres understandable format. Instead, you can use like universally accessible data sets in the JSON format, plug and play in directly. So as a developer, your mental workload of just converting from one format to the other is eliminated completely. You just have to focus upon the actual logic building that's out there. With PL Python, the advantages is that you can write Postgres functions right in Python as well. You can access Python's rich ecosystem of libraries. So think of every possible library that's out there, right from SciPy to like plotting libraries to to a lot of existing models that are there, wherein you can just tweak the parameters and make use of it. You have that already, and any advancement in the space of Python scientific libraries is at your disposal. You don't have to wait for that feature to come into Postgres as separately, because you're able to make use of Python inside your application. And there's seamless integration with database operations. A key reason why this, or like the topic that I have, is very successful in the industry is that the seamless integration. You as a developer can succeed much higher when you don't have to spend a lot of time in just converting from format A to format B. Instead, you are focusing on building the logic and directly implementing it, getting the results. And that is the ultimate aim that a language or framework should provide. And that is what we get in Postgres with Python as well. So let's look at implementing ML models. So we are going to implement ML models directly within the database using PL Python, and this opens up the new possibilities for real-time predictions and data-driven decision making. So let's look at serialization and deserialization. So serialization is the process wherein you convert a complex object that could be like a trained machine learning model into format that can be easily stored or transmitted. Say if you're building a complex model, you want to use it in a lightweight fashion. If you serialize it, you now have the object which you can plug and play in. And deserialization is exactly the opposite, exactly the reverse, wherein you're reconstructing the object from the serialized format. So to have a mental model, you can look at, like, you've developed a model, you serialize it into a very compact format, which can be understood, and then you make any kind of predictions, modifications you want, and if you ever want to deserialize it, you have the ability as well. With database storage, they typically store structured data and not complex Python objects. The result of your ML model, once you've trained it, would be a Python object. But serialization is what allows you to convert it to a binary data format, which you can then use it in your application, directly store it in the column. Here we are so there is the module called the pickle module of Python that is very key in using machine learning with integration with Postgres and Python. So if you ever want to look it up or just want to deep dive, look up the pickle module, and it is really good documentation that you can then dive deeper based on your use case, and you'll be able to create a lot of great things. So a summary of how it exactly works before I dive into a code example. Firstly, after you train the model, we use pickle.dumps to serialize it into a binary format. After that, it is stored in the Postgres column, and when we need to use the model, we retrieve the binary data and use pickle.loads. So basically, you have pickle.dumps, you store it in the column, and then you use pickle.loads, wherein you're deserializing it, and then using it into it. Then after serialization, it converts back to a Python object, and you are able to use it. Quickly, how do you actually set up the environment? So PL Python 3U, you would create an extension of this that will help you enable it. After that, it is as simple as this to create a sample database wherein we are making use of, say, age, income, credit score, and purchase amount. And directly I have different values. So this could be huge amount of data. For simplicity and to understand the core logic, let's go with this smaller set of data set. So this is a table that I've created, which is my database or the data set I'm working with. After this, we look into implementing ML models in it. Say I want to create a linear regression model and taking a very direct linear regression example of y is equals to beta naught plus beta 1 x plus a constant, and that constant is going to represent error terms, so that if you want to manipulate your parameters and see if you're getting the desired results or not. And we are assuming that there's a linear relationship right now between the age, credit, purchases. So this is how the linear regression model would look like. If you have a look at it, you will see that it is as good as you writing a linear regression model in Python. So you are importing pandas, you're importing pickle, which as mentioned earlier is required so that you're able to transform things between database column objects and Python, and you write it as you want it. So we are directly making use of all the capabilities of pandas that are there for any kind of transformations. You can include any and every possible Python library that you want. And again, then I'm preparing the features and the target. So I have my X defined, my Y defined. I'm trying to predict the purchase amount based on somebody's age, income, and credit score. And for this example, I've considered there's a linear relationship between the purchase amount and these three factors. And then I'm training the model. The benefit is that because we are making use of sklearn, we are directly calling linear regression. So as a developer, I did not have to go ahead, define something that has already been defined in Python, and if it serves my purpose. So I can directly do that. If required, I could have modified the parameters inside the brackets for linear regression, and then I'm fitting my model. And then, so till this point is when we have fit the model, but we'll have to deserialize it before we come back outside the Python space and back to a Postgres space. So that is, for doing that, I'm going to serialize it, and I'm returning pickle.dumps for my model. And with this, then I have a table wherein I have included my purchase predictor for my train model. So as a summary, we have done everything in Python. So if you wanted more factors, if you wanted to modify things, you wanted to try out different models, you would have done it right here. And once you have it, then you're done with your ML model part of it. Now we are going to create a prediction function. So for a prediction function, again, if you see, I'm going to import pickle, then out of sklearn, I'm importing linear regression as we are working with a linear regression model. I'm fetching the model that I had stored earlier, and then I'm loading the model, and then I'm making the prediction. So in the variable called prediction is wherein I'm having the model.predicate based on the three factors that I have, the age, income, and credit score. And then whatever is the prediction, I'm returning the 0th element of that. So again, if you see, all of this is Python inside of your Postgres. And this is what makes it very, very powerful. Right now, how many of you like feel, if you know Python, if you know what to do from a machine learning perspective, and you're good with databases. Now this has given you the perfect tool wherein you're able to combine the two worlds and not spend a lot of time in the integration part, but actually on the model and how you want to use the results and how do you want to actually have your inputs. Say you're modifying your inputs in a simple workflow. Say you would work completely in Python and you're developing an application, but you want the power of databases. You have huge databases and you want to incorporate it there. Now you have a way wherein you don't have to learn something new. It's not like you have to learn a new scientific language and then incorporate it in Postgres. You have the liberty of using Python, which a lot of us will be able to pick it up very quickly, even if you have not used Python a lot, because the syntaxes are very simple, and the community behind different Python libraries. You're going to see so much innovation happening there. You'll be able to pick and place a lot of things out of the community and solve for your use cases. And that is what helps with the real-time prediction pipeline as well. So you want to integrate predictions into queries. So consider this example wherein I have my ID, like a unique identifier, age, income, credit score, and then I have predict purchase, which then is sending in the age, income, credit score, and as a predicted purchase from customer data. So that way you are injecting predictions right inside your queries. So for somebody, say you work in a team of 5 developers, you're the one looking after the ML aspect of it. but other folks in your team are more like database experts. You have your model and now they want just the final way of how do they include this result so that they're able to integrate it with their web page. That is wherein integrating predictions into your queries comes into place. And it is very readable. Even if the other person does not have any knowledge of machine learning, it is not difficult for them because it is in a very readable format and is following the structure, the syntax of their normal queries. Now let's look at triggers. So triggers are for automated predictions. Now there can be a lot of triggers that you would want. Like you're predicting a lot of things. How many of you like must have, just a show of hands, how many of you have used like aggregator websites to book flights or hotels? Yeah, most of us. Instead of going to one particular brand, we generally go to aggregators and then look at different prices across different airlines, different times, right? Now imagine, and a lot of you must have also seen the pop-up of like, 10 people are looking at it or the price is jumping because there's like too many requests happening. A lot of it is marketing, sure, but a lot of it is also real time. So they would also need a congestion pricing concept, and that is wherein you would require like a real-time pricing in e-commerce and aggregation websites. Now this kind of a predict function, like I'm trying to link both the things so that you see the power that you can have with integrating predictions right in your queries. So any kind of real-time pricing that you want to do, you would want to integrate some trigger and that would trigger your prediction pipeline. Or predictive maintenance in industrial settings. Large settings would require a lot of triggers. Only then you would want to perform a maintenance or some action based on it. And of course, personalized content recommendations. All of us are on some or the other social media platform or use it in some or the other form in our everyday lives. And you want personalized content recommendation. So it is again a kind of prediction. You have now like purchase options right in your social media. You see buy now in Instagram and Facebook, any and everywhere. So the way the consumer is buying and interacting with products has changed. And a lot of good implementation of triggers is what is helping weave two different worlds of e-commerce and social media together. And another one is fraud detection in financial transactions. So fraud detection comes in many, many formats. It could be something related to money laundering. So all financial institutes spend a lot in anti-money laundering. That again is a financial fraud that is prevented based on different triggers. Or if you say as simple as if you have a mismatch on your signature in a check that you're depositing in the bank. So somebody could be like impersonating you and is trying to like make a similar signature. Like one is detection of that signature and voiding it, but it is also again a trigger which is preventing money being transacted between two accounts. So triggers are very crucial when we look at what is the application of actually having machine learning or predictions in Postgres and Python world. So while triggers are very important and very crucial, there are like three key challenges that come with automating predictions. One is database performance. You want every possible consistency in your database. You want the performance to be high. You don't want different regions, say in the banking world, if it is across say LATAM and APAC, you don't want time differences or some other latency delays causing any database performance issues. Another thing to think about is scalability concerns. Say you are a new age brand who has started selling something online. It's a product based, like a physical product based startup, and you have predictions on like you want to pop up personalized recommendations and ads for loyal customers or people who are visiting your website frequently but not really buying on it. So it could be region specific early on, and once you scale it to say all cities in India, the kind of consumer interaction you'll get will be very, very high. So scalability concerns is something you should think before you place a trigger. What happens down the line is, say day one, if we take say the whole year, say January, you have launched a few triggers, say for Mumbai. And down the line 6 months, your product is doing really well and now you've decided to expand it to Delhi. Now, you would do a lot of market analysis as to like your product's demand in Mumbai versus Delhi based on region dynamics, based on seasons, based on the way the consumer actually buys things or not. But say Delhi, that product, like if you had expected like 10x the customers, now it is like 100x the customers, because maybe your Delhi region is not just Delhi, it is Delhi NCR, which you as a developer had not thought of. Like it is a different team that has thought about it. But your trigger, you just like had it for Mumbai, and then you extended it to Delhi, but now you are not able to handle the scale, and that is leading to incorrect triggers and maybe a loss to your product line or company. So very important that any trigger you write, and that is something that say the management or people in front who are looking at sales and marketing would not know why it is not working. But you as a developer, knowingly or unknowingly, did not realize the scale at which your trigger can create an impact. So having triggers for automated predictions is very good, but do create it such that it has fallback options for scalability, unexpected issues, and keeping models up to date. So a lot of models do really good even across decades, but given the recent advancements in machine learning, models, training, the accuracy increases, the recall changes, all of that, it is very important that you keep your model up to date. Otherwise, the drawback here is that you would not be leveraging the 100% potential of that new model or parameters. You'll still get results, but those might not be the most optimal as what you want to expect as compared to what's happening in real time across the globe. Now, if we look at creating a trigger for real-time predictions, so we can automate it directly with Postgres triggers, and this trigger will automatically calculate and store a prediction when a new data is inserted. So if you see here, it is as easy as this, but of course with complex applications, you would have a little more complex application of this. What this is helping you do is you are updating the predictions where any new age, new income, new credit score is identified. Now, this is very much possible new age in the sense, say, if your user is say 13 years old, so user 13 to 14 would maybe not trigger a change in your model's result, but when the user turns from say 17 to 18, the user might get a job as well, or when the user graduates college, say 21, 22, those changes in age will also create a trigger, which many times we would not realize in hindsight. And of course, income and credit scores are very dynamic based on somebody's purchases, their repayments of loans, also their purchase capacity increases once somebody who was say a student to somebody who's now earning. So all of those factors then need to trigger a new purchase power that we are predicting in our current example. So those things are very real time again. And all of that comes in handy when we have triggers for real time predictions. And once you have a new real-time prediction, you would want to insert new data and get the real-time prediction. So say if I have a new data for like 30, 60,000 and 720, and then I would want to get everything out of my database. So this is an example of a real-time data that I'm inserting. In a real scenario, you would have a pipeline, an ETL pipeline, wherein you have constant signals of data that are coming in, and for each of the signal, you are then triggering the trigger you have written in your code. And again, once you have new data, you realize now that the model that we had trained upon, that data also is changing. So that might also change the pool of customer data that we have. So you would want to retrain the model with all available data, new as well as the existing data. And in order to update your models, it is as simple as these 3 lines. So you're trying to update the ML_models we created. You set the data to train model, wherein you have both existing as well as the new data. And then again, you have trained the new model, and you have, so purchase predictor is the model name we had given to our model. Now, let's look at a few best practices. Throughout this, you've seen, like, one is how do you actually include a ML model right in your Postgres application. And a more key part that I personally am more interested in is handling real-time data. We can work on existing data and create like a good POC. But to take that POC to production is wherein real-time data handling is important. And through different examples, you saw that handling real-time data is complex, but it is not unachievable. That is what I would say. Like if you just give it a thought, it is very doable and just an extension of working with static data with real-time data. You have to tackle the challenges of real-time data, but that is what brings your POC to production. A few best practices. First is very regularly update and retrain models. With models, retraining is important. If you have new improvements in the models, plus once you have new data, you would also want to leverage insights out of that data and make the most of it. Monitor model performance. This is very crucial, especially when you as a developer or somebody who's a machine learning engineer had a set hypothesis that this is the best way to solve my use case. But what if actually it isn't? There's something better in the market, or maybe you were off in your calculations. If you're not measuring, you'll not be able to improve. Measuring things is, or like measuring model performance is crucial to achieving the best kind of results you want. Handling errors gracefully. Every application has bugs. It is how do you handle those errors and are you logging them correctly? If you have a good log and a good documentation of errors you're getting, you'll be able to solve it, overcome it, and make your application robust. Don't leave errors hanging. It is not going to help, especially you as a developer in the long run. When people come up to you with issues, you don't know where to look at or where to solve at. And it's going to put at least like extra days of like developer cycles into just detecting why something is failing to what the error is. And once you know the error, then you have to like actually sit and debug what is causing it. At least try and eliminate the first part so that you know what the error is. Then you have to actually debug, that is okay. And optimize for performance. Always while developing, one key aspect that I think whenever I'm developing something is, what if I was the user? What is it that I would want? So optimizing on performance that the user, it could be a B2B, B2C, any user, but what would the user want? Is the would I be okay if the latency is the way it is? Would I want a faster application? Am I okay if my page 1 to page 2 is taking say more than 50 milliseconds? Or is this something I'm okay with? Or is this something that has room for improvement and would highly improve the performance of the application and in turn improve the user experience? So always optimize for performance. Before I end, a few takeaways. Postgres and PL Python enables powerful real-time predictions. All of us have tons of data. A good way, if you all want to try out a good project on your own, just to make use of the learning you have through my talk. All of you have social media. You have constant input of data that you have. Why not create something out of that real-time data? Or you are, say you're wearing a watch or something which has a sensor which has constant real-time data. So why not make use of that sensor data, create an application that will be useful to you. So you have a source for real-time data already in your houses. A lot of folks after the talk generally ask me like, this is good, I want to use it, but I'll only be use it in a real-time like work setting. No, you have a lot of sources which are creating a lot of real-time data. Why not make use of it and create something interesting that will give you the confidence to do it production scale as well. And there's seamless integration of ML models into database operations. So just try and learn more about machine learning, and you being good at databases will be able to, it will be a unique skill you have that you'll be able to actually implement and be ahead of the curve. And potential for enhanced decision making and user experiences. When you have better predictions, once you have better results through ML models that you have, and it's right in your database. Think of it as making the most of data. Data is the currency of today's world, right? And databases are what have data. With machine learning, you're able to leverage the most out of that data. You'll be able to generate insights, generate predictions, generate modifications that would be required, all in your database world itself. So yeah, that's it from my end. Thank you. I'll take a quick selfie with everybody for my social.
Excuse me, I have a question.
Yes.
So have you integrated this with SPSS to get those statistical futuristic
Yes.
guidance?
Yes, I have done that in case of especially like trading, like in the financial space. That is where I've done it with SPAS.
SPSS.
Yeah.
Say, for example, I'll just give you a simple example.
Yes.
If the economy improves, your
Yes.
GDP will improve.
Yes.
There'll be more money in the hands of an individual.
Yes.
So, in all likelihood, FMCG companies will do well.
Yes.
So, a simple regression kind of a scenario.
Yes.
So, have you used something like this earlier through integration with SPSS
with the-
rather than using Python scripts? Because this is all inbuilt and it's plug and play.
Yes, this is plug and play. So I've used it for a different logic on a personal finance level that I've done, and I've gotten good results, made good money with it.
Okay.
So it is good, but instead of just relying on, say, predictions like, say, GDP, and that would lead to FMCG increase, another factor to consider, say, sentiment of the news. Like it is, there are a lot of Python libraries that will help you extract news articles. You can, even if it, now you have LLMs, so you can like kind of summarize it, take out words out of it, give a sentiment score to it, and that can be another factor.
Okay.
So because right now, I think across the globe, the market is able to sway based on what the sentiment is as well, instead of just like traditional parameters. So the advantage with something like this, wherein you're plug and playing it, is you can, it's all about the logic you create, and it's very easy to like incorporate it, see how it is doing, and go ahead with it.
Thank you.
Yeah. Awesome. Take a quick selfie before I answer questions. Okay. I'll have to take it in two parts. I'll take this part, please. Yes. Yeah. Awesome.
Thanks a lot, Drishti.
Okay, awesome. I'll be around if you have more questions. And I'd really say that, you know, there's so much you can do with real-time data, even on a personal level. Go ahead, try it. Yeah. Thank you.
Thanks a lot, Drishti, for your insightful talk. I'll request Tushar sir to come and felicitate. Okay, so the next talk we have is from Manan, who is from Supabase. He'll talk more about multi-grace, horizontal scaling, and sharding. Recently, there was a blog that came from OpenAI of scaling Postgres for millions of writes, and we all know it's a real challenge, and it's very good to see that Postgres is the backbone for such system, right? And sharding, horizontal scaling is also a key component for scale. So I'll hand over to Manan to get into this.
I am still not seeing it. Okay, just reconnect once. Yeah. Entire screen and start.
Yes.
Oh my God. Well, is this visible now? Okay. Hello, folks. Is the volume fine? Is the volume fine? Everyone can hear me? All right. Hello, folks. I am Anand. I am a founding engineer for Multigrass. I work at Supabase. Previously, I was a maintainer for Vitesse. Before we dive into the architecture of multigress and what my talk is about, the features that we have, I first want to talk about what are we trying to build. What is multigress? Some of you who are familiar with Vitess, you'll know that Vitess is a sharded solution for MySQL. And it's massively scalable. It's used by GitHub, it's used by Slack, it's used by many other bigger companies to run their databases. And that is the kind of goodness that we want to bring to the Postgres world. So multigress is going to be a sharded solution for Postgres. But it's a lot more than that. We're not just going to solve sharding. We're going to do high availability, connection pooling, migrations, backups and restores, and a lot more. Now, some of you will ask that we have a lot of tools. We've seen people have talked about Petroni, Rep Manager, so many other tools, PG Bouncer. Why is multigress doing all of these things? Should we just not build a single sharding solution and not spend our time doing everything that we already have tools for? To explain our mindset, to explain where we're coming from, I'd like to take an example. Let's say you're all Postgres developers. Let's say you decide to do a startup of your own. And you think that Postgres is great. It's on the upward trend. We saw the graph that one of our colleagues showed us, that Postgres is going up and it's really good. So you've heard good things about it. You start using Postgres. Okay, great, good decision. You deploy your application and you've deployed multiple instances of it. And then you realize that Postgres does not give you many max connections. And you've got these many application instances deployed, each requiring connection of its own. You think, okay, I need a connection pooler. You look at the existing tools that you have, PG Pool, PG Bouncer, PG Cat, choose one of those, problem solved. The next thing you realize that, oh, I don't want my customers to suffer if my database goes down. So you now add high availability into the mix. So again, go back and look at the tools that are available. You look at Petroni, you look at Rep Manager, you choose one of those, and now you've got that as well. Okay, now your application is massively successful. You're not the only developer working on it. You've got more people and everyone's working on it together. And you realize it takes one bad merge, one bad commit, and something could go horribly wrong in your database. We've seen that explain, analyze, you run it with a DML, TDL, it actually could execute. So to protect yourself against all of these problems, your next thing is that you want to take a backup and you want to have the ability to restore a previous backup in case something catastrophic happens. So you again go back and you look at the ecosystem, you figure out what are the tools I can use. You find out there's PG Backrest, there's other tools, there's WallG, you take one and you use those. But what has happened is that as a developer, you signed up to use Postgres, but you've ended up mixing and matching it with many different solutions and tools that are existing, and it's now your burden to also maintain them. Not just maintain them, but also make them work together with each other. So when you're running PG Bouncer and you're running Petroni, you need to configure PG Bouncer in a way that it's aware, oh, Petroni is run a failover, and I now need to send my traffic to the new primary, which is running in a different system. And that is the problem that we want to solve. In multigress, we want to build a single ecosystem that doesn't just do one thing, it does everything. So when you decide to run Postgres, when you come on to multigress, all of your problems are solved for all the things that you would require to run Postgres at scale. We want to go from fragmentation of different tools into a unification for a single one that solves all the problems. Now, we're still open source developers, and we would be remiss if we didn't find the value that all of these open source tools are providing. So when in multigress, we were looking at how we want to do backups for our customers, we thought that PG Backrest is amazing. It's doing everything. It's already written all of the code that would be required to take backups, do restores. It's very scalable and it's very, very fast. So we don't want to reinvent the entire wheel. All multigress is doing is that for backups, we're still using PG Backrest. We're just doing the orchestration to make it work with all the other features that we'll add. So we're still leveraging the entire ecosystem. So this is the goal that we've set. This is what we want to build. The next thing I want to talk about is how does the team think? How do we go about building something like this? Our first principle that we added was we don't want to accept accepted problems. From the Vitess world, we're bringing a fresh pair of eyes and we want to see all the problems that the existing frameworks have. Are they real? Can we solve them in a novel way? Can we take some of the pain away? You can actually hold me to this statement because when I go over the architecture and showcase some of our capabilities of multigress, I'll explain one of the problems that we've solved that currently exists. The next thing is something ties back to what I talked previously about. All of these features, they needed to be connected and they need to connect well enough that when as a user you're using multigress, it should feel seamless. Our intent is that once you use multigress, you don't want to go back. Like multigress becomes the default way for running Postgres. That is the lofty goal that we've set for ourselves. We want it to feel painless and seamless for you. And it's like a hard problem. It's not an easy problem, but the point is that it should be hard for us as developers of multigress, but not for the users of multigress. I'm going to quickly talk about some of our design principles as well. Then we'll go over the architecture of multigress.
The first thing is that multigrace is going to be a distributed system, and we want it to be simple enough that we can keep adding more features. If we let the complexity go out of hand, then very immediately we'll find ourselves in a situation where, okay, if we want to add a new feature, now we've got to look at the entire architecture and rework so many more things. So our first principle is we want simplicity. We want to limit the number of moving parts, and we want to limit the surface area in which these moving parts interact with each other. For the life cycle of multigrace, we think we can live with 3 components. We're going to live with 3 core components, that is multi-gateway, multi-pooler, and multi-org. The reason we think we can do this is because we've done this in the past. Vitess also had only 3 core components, and we're adopting the same architecture. The surface area in which these tools, these services interact with each other is also very limited. They adhere to an RPC framework, and that's the only way they interact with each other. The responsibilities are separated out. The next is survivability. Again, because multigrace is a distributed system, we're going to run many instances of all of these services on sometimes hardware which is not reliable. So we don't want our system to go down in case a single failure happens. So we don't want any single point of failure in our entire architecture. And finally, the most important one, no humans. We don't want any humans to be involved in the multigrace ecosystem, in the sense that there should be no problem that multigrace says, oh, I've run into this situation, I don't know how to proceed, somebody else has to come from outside and give me these commands or run this, fix this for me, then I'll proceed. Whatever an external agent does, multigrace should be able to do internally. With these design principles, I'll go on to the architecture. I hope this is visible enough, because I don't really have a way of zooming in. So.
What is the use case where this will be a requirement before we implement it?
The requirement for multigrace, it's mostly for the point where I'll actually go over the exact benefits you're going to get, but the entire the main benefit of multigrace is going to be when you reach a scale when you can't keep all of your data in a single Postgres instance. So think of like Slack scale or GitHub scale, when your database has now gone into multiple terabytes. So you need many instances of Postgres running, and that's when multigrace will provide the value, because from your application perspective, we still want everything to look like you're connected to a single Postgres. And that is the major value add that multigrace will provide in the eventual term. To begin with, it's going to be unsharded. We're going to add sharding eventually. But even then, to begin with, you'll have HA, you'll have connection pooling, all of the other features working cohesively in a single unit. So in this architecture, I want to showcase, we can see 2 of the core components, 2 of the 3 core components. There's multi-gateway over here, which is the layer that talks to the application. So your application connects only to the multi-gateway, and it uses the same Postgres protocol, because from your application perspective, it should not feel any different from Postgres. On the lower side here, we've got the database, the Postgres instance running, and with every Postgres instance, we'll have a multi-pooler running. And what multi-pooler does is actually in its name. It does connection pooling, so it's called multi-pooler. Along with that, we've got 2 additional components, topper server and the provisioner. Topper server, we're using etcd. It's just for discoverability. So all the multi-poolers and multi-gateways will register themselves there. They'll publish their IP addresses, and that way other instances can find them. And finally, provisioner is another non-core component. It's the way that you tell multigrace to bring up. So new services. We've got 2 implementations. We've got a local provisioner, which pretty much brings up multigrace instances as services, as processes on a laptop. We use that for local testing. And we've got a K8s operator, which makes it cloud native. And you can run it on Amazon, your own hardware, bare metal servers, whichever you choose to. You can also write your own operators or own provisioners, and that will also work. Now, one question that arises when people look at this architecture is, why is there a separation between gateway and pooler? Why not a single one? Why don't we just have one, like we take this multiplex gRPC part away, have one instance that takes the client connections, also does the pooling, and does all of it? Why do we need 2? And there are 2 very good reasons for it. The biggest one is what I just talked about, it's sharding. Because when we go sharded, in this example, in this diagram, you only see one. But eventually, you'll have many Postgres instances and many multi-poolers. And it's going to be the gateway that when it gets the user query, it'll do the planning. It'll realize, okay, I need to gather information from more instances than one, gather all of that, possibly do aggregations, also do joins. It'll do some complex operations if required, if it's not a point query. If it's just a point query, then it's just do the routing that, okay, it goes to this pooler, serve the traffic from there. Which is why we need this 2-tiered architecture eventually when we go sharded. But that's not the only reason. The other reason is because multi-gateway is the layer which is accepting the client connections. In our architecture, you can horizontally scale gateways. We would actually want you to, because we don't want a single point of failure. You should have many gateways running. which means that your connections from the client side can scale irrespective of your Postgres instance. So you can have a single pooler which has like a connection pooler running here with 500 connections against Postgres, but you can horizontally scale your gateways and have 20,000, 50,000, however connections you want. Of course, your total QPS is still limited because you're pushing everything to Postgres.
Each gateway will access all the Postgres?
Yes, it will connect to all multiple instances. So if you got multiple, you can restrict it. You can say you can have a division between there that, okay, this gateway only connects to this subset, but you will need, then you'll also need to be able to say that you won't issue it queries which require any of the other ones.
If this shard was corrupted, like do we have replicate?
I'll get to that. It's in the next slide. So I'll actually take questions once I go over the entire architecture. Okay, where was I? I was talking about the gateways, and yes, you can horizontally scale those and have as many connections as you want. The QPS itself is going to be limited because everything is still going to a single shard right now, but eventually if you want more write QPS, then you go sharded. In this diagram, we see the final core component of multigress, which is multi-org over here. So like the gentleman just asked, what happens if a Postgres instance dies? And this is where that thing is visible. So this MDB1 is one primary Postgres and a pooler instance, and we've got that replicated. So we've got 3 of those running, and the high availability component is multi-org, which itself you can run many instances of because no single points of failure. And multi-org is the one that will wire up the replication. It will keep track that, okay, is the primary still available? If it is not, then it will do the failovers. All right. From this point on, I'll go and talk about a little bit of query serving, which is the predominant field that I work in multigress on. Before I do that, I want to take questions in case anybody has anything about the architecture that is unclear. Please go ahead and ask those. We have a couple of minutes. So right now, we started on this project 6 months ago. It is open source, so you can check out the development and everything. Right now, there's nobody running it in production, but we want to get to GA soon enough. It is going to be deployed on Superbase to begin with, but it's an open source project. Anybody can do that. Superbase, the company that I work for, Superbase, is going to deploy it, but it's open source, so anybody can deploy it. We'll actually have a self-hosted service as well for it. No more questions? Oh, there you go, please.
Because in other cases, it will be like coordinator that will be aware of the data, right? It will
So
have the metadata.
I'll repeat the question so that everyone understands. The question is, when we go sharded, how will the gateway know where what data lives and what the sharding scheme is? That generally is configurable. So the way that it happens in Vitesse, which I don't know whether we'll do the same thing, but it's likely we might. The way it happens in Vitesse is that you have a V schema separate where you say that this table is sharded by this column and you have a hashing key for it. So let's say you have a primary key, you use that, you have a foreign key, you use that. You can also do secondary indexes. It gets complicated as to how you want to shard your data. You have geo sharding, so many other variants of it. But essentially, there is a configuration which says this is the column that I want to shard on, and this is the way that you get to which shard it's on. So once you have those, if someone says like select star from where ID equals 4, then you take that value 4, you hash it, and that gives you which shard the data lives on. Does that answer your question? Okay, cool.
Is there any restriction on the database side of sharding for this specific architecture?
Not that we've seen so far. There is of course some theoretical limit because at some point the number of network calls you have between gateway and pooler itself will crash. But right now, even the biggest of companies haven't hit that scale. Yes. Multi-gateway is not. Vitesse is. Multigress is still in production. Is still in development. But Vitesse is running. It's a solution for MySQL. So it's GitHub, Slack, companies like that. It was actually built at YouTube originally. So hopefully, when we do have multigress sharded as well, it'll give you the same scale. Okay, let's move on. So query serving is the part that I work on. So when I started at Superbase and we were contemplating, okay, we need to start working on query serving. The first thing that I did was add a Postgres parser, and it was a massive undertaking. It was almost a 280,000 line PR. It took me 2 months to do this. And I have a blog post that I actually published yesterday. This is the QR code for it. If you're interested into how I went about that business, I'm not going to talk about that right now because that's not what this talk is about. But what I do want to talk about is answer the question why we needed the parser and why was it the first thing that I worked on. You would think that the first thing would be maybe the Postgres protocol, maybe the client protocol to talk to Postgres, maybe the server protocol to support some queries, but it was the parser, and it took me 2 months. And the reason that I did this is because it helps us understand the queries. And we can do some really, really cool things once we understand those. And I'm going to talk about some of those features now. The first one is prepared statement consolidation. And I'll go back to the same example that we were discussing before. Your application has been massively successful and you have many, many instances of it deployed all across the globe. You've got many, many customers. Everything's looking up. You're a good Postgres engineer and you read the docs and you realize that if there is a query pattern that you're using over and over again, you should use prepared statements for it. So that's what you do. You start using prepared statements. But what happens is that you've got many, many connections to gateway and each of those connections is creating a prepared statement. So your problem now looks something like this. You've got your application, you've got many connections to the gateway. Each of that is creating a connection, is creating a prepared statement. And if you push all of these down to Postgres, it will crash because we've got 20,000 client connections. And if you pushed 20,000 prepared statements onto Postgres, it'll run out of memory. We can't do that, but we do want to support all of this because we want our system to be agnostic. You should not, from a user perspective, from the application, it should not feel you're running anything other than Postgres. So what do? What we do is we understand the queries because we know that the statement 1 is preparing this query, select star from T1 where ID is question mark. And the second statement, statement 23, is also preparing the same query. So at the gateway, what we can do is we can create a map where we say that this query on this connection is preparing this said query. And we can consolidate all of those and pass on a single prepared statement onto Postgres, serve them all through the same one. This is what it looks like. So this is an example I've taken from a running instance where this is the query that is prepared and this is the output name that we've given to that said query. And these are the number of connections that are using it. So you've got 8,000 connections onto gateway, all of them creating this query with different names, but we're consolidating them all together into a single output map. So when it comes out from the gateway, there's only one prepared statement that's it's issuing. It is, I'm going to answer that. So in this diagram, I showed you the problem was between the app and the gateway. So we were going to run the prepared statement consolidator at the gateway. But if you look closely, it's the same problem on the pooler as well, because gateways are now clients for the pooler, and they're also going to issue prepared statements to the pooler. So you've got the same problem, but on the lower list of arrows as well. We've got two ways of solving this. One is maybe we can get all the gateways to coordinate where for a given query, they give you the same output name. And you can do this by hashing. Let's say in the previous example, you had select star from T1, ID equals to question mark. You hash that, you use MD5, whatever output name you get, that is the name of your prepared statement. And if you do that, then all of your gateways will assign the same name to all the same prepared statements, right? All the same prepared queries. That solves the problem. But that is not a good solution, and I'll tell you why. The reason it's not a good solution is because it massively complicates your upgrades. What do you do when MD5 becomes a hashing algorithm that people have broken and you want to use something else? Maybe Scram SHA-256. What do you do then? Because you can't take all of your gateways down together. What you'll end up doing is a rolling upgrade. So you'll add a gateway, you'll take one down, you'll add another one, take another one down. But what that means is that while you're doing upgrades, you've got old gateways and new gateways both running together. And your application cannot depend on having this coordination across gateways where it's dependent on correctness or performance based on them using the same hashing algorithm. And there's another solution, and it's actually based on how I stated the problem. It's the same problem, so we can use the same solution. So you just run the prepared statement consolidator, but also at the pooler. So the prepared statement consolidation happens at both the layers. It happens at gateway, and then it also happens at the pooler, which ensures that finally when a prepared statement reaches Postgres, there is only one for a given query. Okay, that was pretty long. I've got a little bit more time, so I'll talk about some other cool features that we have. The first one is, and this ties back to the thing that I said before, that we don't accept problems and we think we can solve some of those. So when you use PG Bouncer, it makes you upfront tell you, are you going to run it in a session mode, transaction mode, or a statement mode? And that is not a limitation that you have with our connection pooler. The reason is, again, it ties back to the parser. Because we've got the parser, we can understand queries in a lot more detail. What that means is that when you connect to multi-gateway and you start issuing queries, it's running in the statement mode. Everything's going through the connection pooler, everything's great. At whichever point you issue a begin query, we track that. We know, okay, it's a begin query, we've understood it. And at that point, we'll dynamically transition into a transaction pool mode, and we'll give you a connection that will live with your, that will be tied to your connection until you commit, until you finish your transaction. And at whatever point you start using a created, like a temporary table, you create a temporary table, we'll move into a session mode and we'll keep that connection pinned for you until your entire client session dies. So we can transition between these three different modes based on what your usage is without really impacting. So from your user perspective, you don't have the headache of configuring, okay, I've got one PG bouncer which is doing statement one, I've got one which is doing transactions, and I have to ensure that transactions go this way or that way. Just use it like a Postgres. The next one, we actually don't have this, but it is very easy to add. It's prepared statements in the simple protocol. This is also very easy for us to do because we parse the queries. When we get a statement in the simple protocol which says prepare STMT1 as and the statement, we know what the client wants us to do, and we can just do the same thing we're doing for extended query protocol. The reason I say it's not there is because I've left it out so that someone here, if they're attending the talk, wants to contribute to multigress, they can. It's only 20 lines of code. I've tested, I have tests for it, but I'm not pushing it because I want someone else to contribute it. So this is a good starting point to get into multigress. And the final one that I'm going to talk about is set statements. This is something that we're actually inheriting from the Vitesse way of connection pooling, where even set statements work through the pooler. And I'll showcase that with some diagrams. So our connection pooler initially starts with a bunch of buckets. 3 is this representative. We actually have more, but to begin with, for this example, we'll consider that we only have 3 buckets, and you initially have all clean connections. And I'll go back to the previous example that we have. Your application we've already concluded, it's massively successful. Many people are using it across different time zones. Let's say you want to add a feature, and the feature is something that is dependent on the clock time that the user is seeing. Their clock time, not UTC time, but what they're seeing. The easiest way you do that is you set time zone to whatever the time zone the user is in, you issue a query, insert, and you use the now function. That works. But what happens when you ask for a connection which says set time zone to Australia? What we do is at the gateway, we keep track of each of the connections that we have, and we keep track of all the connection settings you've asked for. And then when you try to run a query, that's when we ask the pooler for a connection which has these settings applied. So basically what you'll do is you'll go to the connection pooler and say, I want a connection which has these settings applied on it. Pooler will say, I only have clean connections. I don't have any connection with this setting applied. It will take one, apply that setting for you, and give it to you. When you return that connection, it's not going to clean it. It's actually going to keep it in a separate bucket. And it's going to keep track of, okay, this bucket now has connections with this setting applied. And you can keep doing this. So you've got set time zone Australia. You also have set time zone India because you've got users here too. So essentially, you've got multiple buckets with different settings applied on those. And the next time when you ask for a set time zone Australia connection, we just serve the one that you used previously. What this does is that all your connections are still using connection pooling, and you don't have to reset or set settings over and over again if you have small number of settings. This is very crucial because you only have so many connections against Postgres, let's say 500. If you run with a set of connection settings which are like more than that, maybe 700, 800 different configurations, there's not much we can do about it. We'll just have to reset and set every time you ask for a connection. But that is still also no worse than what we would have done otherwise. The one other benefit that you get out of an architecture like that is we can dynamically change these. So if your user base is in Australia at the time, like when Indian people are asleep, Australian people are awake, they're using your product, the connection pooler will look something like this. Most of the connections will have set times on Australia set. There will be a few with India because we've all got night owls who are working at night, but mostly you'll have most of your connections in Australia. And when those people go to sleep and the Indians wake up, all of your connections will then eventually move towards the Indian side of this, set times on India. Because you'll keep asking for connections. Whenever it doesn't have one, it will take from the other bucket, clean it, apply the new settings, and then keep that. And that is all that I would like to present today because I have run out of time. I can talk a lot about the connection pooler. I actually have a talk at pgconf.dev in Canada, which is going to be only about the connection pooler. I'm going to talk about it being per user connection pool, fair share allocation that we're doing, and a few more features. So if you're interested, please attend that too. Thank you so much. I will take some questions.
Hello.
Any questions?
Hello. Can you hear me?
Yes, I can.
So you said that preparing statements, so many statements would increase the memory. First question is, why is that? Second, if only one connection prepares a statement and some other connection, query fired on some other connection needs to use it, wouldn't that break the transaction isolation itself?
So, for the prepared statements, it's a property on a given connection. you can't create on one connection and use it on the other one. And it's another property that the connection pool attracts. So when you say that you want to use a given prepared statement are also, it works very similar to how the time zone thing I showed you, where there will be connections that have prepared statements on it, and there will be connections that don't, and we'll only give you a connection which has the prepared statements you're asking for. So we won't break those guarantees. Any other question? Okay, so either everyone's understood everything, or I've done a horrible job of presenting.
No, thanks a lot.
We'll
Manan,
figure
for
it
your
out.
Insightful session.
Thank you so much.
Yeah, and the times that you have called connection, I hope everyone also make a lot of connection with each other, the folks that we have here. So I like to call Jeevan to felicitate Manan. Thank you, Manan.
Thank you so much. Thank you so much. Thank you so much.
Okay, so the next talk we have is from Ashutosh Bapat. He's from Microsoft, and it will be a Postgres committed talk. Okay, so yeah, over to you, Ashutosh.
Or you can put it here in the build. Am I audible at the back? So there are quite a few interesting things happening here. I'm a IITB alumni. I passed out in 2005, and that time Kruti Ramamridam was teaching database internals to us. We used to have a tiny paragraph on graph databases in our books. And I used to dream about working, I mean, there was a tiny paragraph on graph databases, a tiny paragraph on parallel databases, a tiny paragraph on sharding, data sharding based on, and I used to dream about, being able to expand those paragraphs into chapters, whether I will be able to at least understand what it goes into all these technologies. Over the period of time, I ended up working on all of them, and recently on the graph databases. So it's a dream come true, and also being able to talk here in IIT Bombay about that is a fortunate coincidence, I would say, and thanks organizers for giving me that opportunity. Second thing, well, how many IIT Bombay students are in the room today? Do we have any? No. We have two alumnus here, and we will remember how it used to be. I mean, you might have got a glimpse of how it used to be to use Microsoft products in IIT Bombay back in those times. It's interesting that I'm from Microsoft talking about PostgreSQL using a Microsoft laptop and slideshow. That's another coincidence. This would not have happened back then. So a lot of coincidences, a lot of memories coming back to me. But we'll talk about graph databases, SQL PGQ, and PostgreSQL, something hot from the community. I'm a major contributor to the community. I have added many features that were talked about in this room today. I have contributed reviews, code in those features. So I'm bringing something hot directly from the hackers, what is happening there, and talk about graph databases today. So what we'll talk about, we'll first talk about graph databases, then we'll talk about SQL PGQ, which is SQL standard, and then we'll talk about connecting these together, PostgreSQL and SQL PGQ. So what is a graph database? Those who know, those who have studied graph theory, they know that a graph is set of nodes and edges connecting those nodes. A graph database is nothing but a database which stores these nodes and the connections between them. Typically, nodes represent entities, and the edges are relationships connecting to node. And now those who have studied entity relationship diagrams or ER models, they will start seeing the relation between relational databases and graph databases, which we will explore more later. So there is an example graph here which has 3 nodes, 2 nodes of one kind and the third node of other kind. The 2 nodes here, Alice and Bob, back again, they represent people, person, and the third node represents entity called group, maybe a group of chess players. Now there are these lines connecting these nodes which represent the relationship between these nodes. For example, Alice knows Bob since 10th March 2018, or I mean whichever way you interpret that date. Or Alice is a member of group chess since whatever that date may be. So there are nodes, there are edges, and then the third thing that this graph has is properties, exactly the thing that we talked about. What is the name of the person, what is the key or ID of that person, what is when did a particular relationship started, and so on. And these properties is exactly what forms the graph databases. Not so much as these nodes and edges, but these properties really form the data that gets stored and retrieved in the graph database. Why do we use graph databases? Social networks, I mean there is word network in it, which is essentially nodes and edges. So to model social networks and understand the complex relationships in those, get insights, based on those insights form recommendations. So recommendation systems, fraud detection, we'll talk about it more, and then logistic and supply chain, again the words themselves have network in it. So logistics and supply chain, they are themselves modeled as a graph, and then you use graph databases to store these chains as well as retrieve information for them. Let's take an example of fraud detection system. Let's say we assume, I mean, we want to detect whether a beneficiary has received sort of bribe or money, quid pro quo money for whatever they have done. These days, these frauds happen in quite complex manner. A usual pattern is that whosoever wants to pay the money transfers the money into multiple accounts, from which they go through a link of transactions, ultimately reaching the beneficiary. Now, just for the sake of fitting that diagram there, I have used, well, still more than 10, 20 nodes, but in reality, this can happen over a very large network. How do we detect this? This data is in banks transaction, or it might spread across multiple banks transactional databases. How do we find out? I mean, imagine writing SQL which goes across these databases and fathoms this information. It's going to be very complex SQL. Instead, if we visualize this data as graph, then then at least what we want to find out becomes very simple, like this. We want to see a path from account A to account B, which is connected by 3 to 6 transactions, or whatever number of transactions you envision that a fraudulent pattern could have. And imagine if you could just write this much and ship that query to the database, and it gives you answer. That's what is allowed using graph query languages. So, over the period of time, the graph query languages have matured, and GQL is almost, I think it's a standard now. There are other languages also which are variants of GQL, but they are for graph databases, which are native graph databases. Whereas SQL PGQ, which was released 2 years back, is 16th part of the SQL standard, and which allows this path, the path that we saw, to be embedded in the SQL itself. And what we are going to talk next is exactly the property graph query features. But before that, is there any question? Okay, so what is a property graph query? First of all, what is property graph? So the word property comes from the third component of the graph database, which is the property of the nodes and edges. The purpose is the purpose of this PGQ extension is to allow SQL to treat relational database as a graph database. The data is already in the relational databases, usually at the edge. If we can just use the same relational data but map it as graph, then we would be able to query the relational database as if it's a graph database, and that's the purpose of this standard. It's part of SQL, 16th part of SQL, and it has now become a standard. Okay, I elaborate. So what a property graph basically maps relational tables to a set of nodes. Additionally, we can add labels to those nodes. I mean, just like what would you do in a graph database, you label the nodes. Similarly here, you label individual relations so that all the rows in that relation get those labels, and then expose the columns as properties of the nodes and edges. We'll explore more on this soon. So there are two constructs that SQL PGQ adds. One, the DDL, which allows us to map relational database to the graph data as a graph database, and then second, query it. So the first is a DDL which creates or operates on an object called property graph. Just like a regular table, this is another kind of object which sits in the relational database called property graph. And a property graph has two kinds of tables. One, vertex tables, and second, edge table. Vertex tables correspond to nodes, edge tables correspond to edges in the graph. Each of them have keys to identify the node or node or an edge. So vertex table get key and edge tables get source key and destination key. Source key and destination key usually usually reference the keys of the vertex tables. The source key refers to the key of the source vertex table. Destination key refers to the destination vertex table. These keys, if you have noticed, they map to primary keys. If you already have primary keys, they are natural candidates for being a key in the vertex in the vertex table, whereas edge tables, the source key and destination key map to the foreign key. So SQL PGQ allows us to map existing relational keys into graph keys as well, and then you can declare what labels a particular vertex table gets, what labels a particular edge table gets, and then declare properties for each of these labels. The second part is the query constructs, which has 4 sub clauses. Graph table, where we specify what property graph to use. Match, where you specify the path, the example path that I showed. Similarly, path pattern you can mention in the match clause. The third is where, just like a where clause that was talked about in the very first talk, which we are all familiar with, which filters out these patterns, and then the columns, which is equivalent to the select, which projects the properties of the nodes. Let's see all of this in action. The same graph database, let's take that as an example. 3 nodes and then 6 edges. On the right hand side you see the graph, and on left hand side you see the relational equivalents of it. So there are 2 tables which are vertex tables, person and group, and then the relations knows and member of. And you will see that each of these nodes have become one row in the corresponding table, and each of the edges have become one row in the corresponding edge tables. So all the rows in the vertex table get mapped to the nodes in the graph table. All the rows in the edge tables get mapped to the edges in the graph table. So here is how you basically convert that relational view into the graph view. You say create property graph Gymkhana, let's call it a Gymkhana graph, and then we declare that person and group are vertex tables. They have label person and sports group, and these labels have properties ID, name and age. Now this is interesting. For ages we do the same thing. We declare age tables, knows and member of are age tables, and then we declare their source key, destination key, and here you will find something interesting. We have declared 2 labels on each of those age tables. One label is common to both of them and one label is different. This way you can classify or sort of relabel the information that is already there in the relational database into graph database. Even if you have, let's say, a data spread across multiple tables which has some common properties, which has some common classes, they all can be labeled as the same thing, projecting similar properties. And then you have labels which are specific to those age tables, projecting different properties. The condition is that each of the labels, every label declaration should declare the same set of properties. That's the only condition that is enforced here. Let's take SQL query example now. So I'm going to give you two examples, one simple example and one slightly complex example. So first is, let's say we want to find out all the people who do not know each other but are part of the same group. Okay. Imagine SQL equivalent of this, you would have to write a pretty complex join to do this, but in map you can write a very intuitive pattern here, that we want to find a person B, a person A, both of whom are connected to the same group C. That becomes so intuitive and very easy to write that soon you would forget that there used to exist some join in the SQL query. Let's talk about a slightly complex query where we want to find all the people who got acquainted while in Gymkhana, because let's say they were part of the same group. So, and now imagine writing a join for this. It's impossible. With SQL PGDay, it just becomes again very simple and imperative here. So what we say is we want two people A and B who are members of same group C, but who became acquainted with each other after they joined that group. So this where clause k dot since, which is knows, so the date they knew each other is later than each of them became member of the group. Let's dwell into further complex example. If this was not enough complex, let's dive furthermore, where you will see an ER diagram of an application on the top and then the corresponding property graph at the bottom. There are 1, 2, 3, 4, I think 8 node tables there, and then probably more than a dozen age tables. Each of those lines represent an age table. What I have shown here is the node tables with similar name, or age tables with similar, node tables with similar color and age tables with similar color are given same labels. For example, credit card, payment instrument of credit card and bank account both get payment as their label with type, limit and expiry as the properties. There can be 3 kinds of customers: person, company or trust. They all now are labeled as customer with the name, address or ID as their properties. Similarly, lists, and then product is just a single number. So this entity diagram can be condensed into a much smaller graph diagram here, which represents the graph database. I will skip over the complex DDL, which you have to do only once, and let's again look at the queries. The first query is, or rather the only query we are going to see for this example is, we want to find all the products which were paid for by the by credit card. What we are looking at is payments with type credit card, which is done by where clause, and what we want is node of type payment, where the type of that node is credit card, and we want that node to connect to at least one order. So a connection between O and then the payment. The second is what we want is a connection between order and product, because ultimately we want to go to product. Now we are using the same variable here O, which indicates that the order here and the order here should be same. So basically now we are connecting product to payment, product for which it was paid by credit card. And then we want to now connect order to payment through customers, like who is the one who has paid for it, and ultimately we join it through product, and the full query is on the top, where we say that we want orders which are connected with payment and connected to the product, and ultimately projecting the name of those products. I mean, imagine doing this in SQL with joins and unions. It would just explode. So this is being brought to PostgreSQL hopefully sooner. What advantages we get is, anybody who knows SQL just have to understand the new SQL PGQ part of it and be able to start using your relational database as if it's a graph database. Simple. It's a standard, so it means portability, interoperability. Application you develop on PostgreSQL can be ported to other database or vice versa. Third, which is most important, unified data management. I mean, we talked about data lake in the morning, and this goes back to that concept, where a single system, single PostgreSQL database you can use as a relational database, and then use graph database for your analytic queries. You don't have to take that data out, put it into graph database, query it, and make sure that these databases are kept in sync. It all happens in the relational database. Plug data lake capabilities into it, and I mean, the opportunity is immense. Performance, we don't have to optimize specifically for the graph database. The query optimization work that already happens and has continued to happen in PostgreSQL benefits graph database, because ultimately the path patterns or the graph query that you wrote got translated into an underlying SQL query. And then ACID guarantees, everybody is looking at transactions and durability and whatnot. And we started with entity relationship model, then we came to relational algebra. So we already have looked at our database as a graph. We are just going to exploit that again and take that advantage, leverage upon it. Of course, I am not saying that the graph database will go away. They are here to stay. Native graph databases, systems which are specifically made to deal with the graph database, they are here to stay because they give flexibility. You can just say insert node with this label and this property, it accepts without any complaint, even if that label did not exist, even if that property did not exist, even if the type of that property didn't exist. So it kind of works as NoSQL, whereas property graphs require a priori schema definition. Graph databases will give will of course invent more and more ways to make storage optimal for graphs. And then I hope graph databases will have better performances than relational databases, which in our experiments haven't seen to be that advantage. I mean, when we experimented with, again, this is not official, but when we experimented with some of the graph databases and then used SQL PGQ, the performance was almost similar. There wasn't much of a difference, but there can be niche queries where performance could be different. Any questions till now? Any questions on SQL PGQ? Do I have time? Okay, fine.
So is it possible to convert a currently existing schema with the relational tables into graph database?
Yes, absolutely. Just
So it has to be like vertex tables and the age tables. So that has to be defined in that way, or it's like the normal table. You can just convert it into graph.
Right. So vertex tables. So create property graph does not create anything new. It just maps the tables that you input to it as vertex or age in the graph.
Right.
That's it. So if you have your data, relational data already, just write create property graph on top of it and it will start acting as a graph database. That's it.
Question. So, are you going to be here? So I'll ask you one question later.
Yeah, I'm here. Okay. Well, we are here for PGDay. I haven't talked about PostgreSQL at all till now. So let's talk about PostgreSQL. PostgreSQL already has few extensions. There is no native support in PostgreSQL for graph databases, but it has few extensions like Apache Age, which came out of Agents Graph, which was a fork of PostgreSQL. And it uses Cypher-like graph query language, but it wraps it in a function call. So it's a bit unnatural or unintuitive to use it. However, once you get used to that fact that it's a function call, then you have to port with dollar or something, it becomes natural. And then it uses PostgreSQL as a storage engine for it and uses the same query engine as PostgreSQL. PG routing is a different ball game. It works with PostGIS and provides geospatial routing functionality. It's not a graph database per se, but when you apply PostGIS on top of it, and it can be used to turn that geospatial database into a corresponding graph database and then query it. But I don't think it can be used for generic graphs. What we are doing is we are bringing SQL PGQ implementation. We are implementing SQL PGQ standard in PostgreSQL. So you could then have graph databases capability in the PostgreSQL itself, stock PostgreSQL itself. You don't need any extension or something. Most of the DDL is implemented. All the tools that you love will be supported. Dump, restore, upgrade, ECPG, talk about it, and it will be implemented. Multigrace will have to improve their parser to include SQL PGQ grammar. Bad luck, but basic query constructs are implemented. Slightly advanced constructs like quantifiers, embedded patterns, they will be implemented as the feature matures, as happens with any feature in the PostgreSQL. If you have looked at partitioning, for example, it was introduced in 10. Over the period of time, now we are in 19, it has continued to improve. We added bunch of features on top of partitioning. Same thing will happen with SQL PGQ, and we'll continue to evolve it. And it is well integrated with the rest of the PostgreSQL ecosystem. So you don't have to, you just have to absorb the new syntax and new standard. The current status, it's on Hackers. The patch is on Hackers. It is primarily authored by Peter Eisentraut, who is a core committee member and a committer in PostgreSQL, and then I have helped him to write the graph query language. It is reviewed by Junwang Zhao, Henson Koi, who were part of Agents Graph. So I think we have enough people who have voted, gave their opinions and worked on this patch. It is code complete. Hopefully it will be released in PG19, which will happen in March. You are requested to participate. You could participate as code reviewers, you could review documentation, review functionality, test it, start using it and give us feedback so that when it lands, it could be directly usable out of box. Well, I forgot to add something here. It's possible that we will label this as experimental feature, not because it is fragile, but because SQL PGQ is a very large standard which will will evolve, will continue to implement parts of that standard, and so there is a possibility that sometimes we will have to change the syntax or the catalogs, breaking backward compatibility. So when you start using it, just keep that in mind. Even though I think the chances are very less, it wouldn't happen, and if it happens, then we will hopefully fix PG upgrade so that you don't bear the pain. Now, last but not the least, you would ask me, like, this is the advantage of PostgreSQL. It's extensible. I wouldn't, it's quite possible. I wouldn't rule out a possibility that someone will come, implement a table M which suits graph databases, and those vertex and edge tables, it will implement using that table M, so that we get even the storage which is optimal for graphs. Then we have query rewrite rules which can be further, query rewrite rule, custom plan nodes, planner hooks, which can be used to optimize it further and convert PostgreSQL into a graph database altogether, competing with the graph, with native graph database systems. Will it have GQL support? I don't know. Pluggable parser seems to be something pretty complicated. There was a talk about Babelfish somewhere. So maybe it is possible. Let's keep our fingers crossed. If not, we have Apache Edge. So your applications which run Cypher can still use Apache Edge and on top of SQL PGQ and get all the advantages. With that, I'm done. Any questions, if at all, or we can talk outside.
Thanks a lot, Arshad, and hope this make to PG19.
Yeah. Thanks.
I'll request Amar from Open Source DB to felicitate Arshad also. Thanks again. So we are almost there, but we are not closing yet. So we'll have some more lightning talks, and then we'll break for tea, which will be the last section. So next we'll start with Virender, who is from Ashnek. He will do the first lightning talk.
Good evening, everyone. Today I'm going to. It's every 5 minutes, like not more than that. Like recently, I did MCP server. So, like as a DBA, I'm very cautious to allowing outside tools to my database, especially yeah, or like is my data is safe, or is my is my data is exposing to somewhere outside world. Like I'm very cautious. Then like it's come to the mind, like let's chatting with my database. So it sound awkward, but then I come to know like MCP. So we I build MCP server for only limited tools as of now. Like the tools right now I develop for health check and performance monitoring and index analyzer um, and query explain. Like these 5 tools I build under MCP server. So as of now, it is in staging state. So it's not in production. Like yeah, I mean, like as a user client, I am using Claude. So when I hit any request to my MCP server, so in MCP server, I'm creating a tools. As I said, like let's say, show me my like is my database is running or not. So then MCP server send SQL request to my PostgreSDB, and my PostgreSDB respond to again my MCP server. Then MCP server give response to my cloud. Okay, then we get a result. Yes, your database is up and running, or your database is not running. Then we'll ask like, check, show me like what is my schema. So then again the process will same. So here we like as we know, like is using, I mean, using AI is safe for database or not. Like this is everyone a main concerns. Like so we restrict user, like security world, like so we allow only read only user. Like we are not exposing any database credentials to my Claude or our own custom chatbot. So we are exposing only Postgres uh, uh, user details in MCP server. So it's a secure. So my cloud cannot see my database user details. So and also like we have one more tool in under MCP server. It's a safe SQL. So by default, safe SQL cannot insert or delete or update or truncate. So it will, I mean, it will not perform any of these operations. Let's say if I ask like drop my user table from my database, then it will give like it will go to safe SQL tool, then safe SQL to go to SQL query, then MCP server try to restrict. Why? Because we already had hard coded restrictions in SQL SQL query. Like if any operations such as insert, delete, update, truncate, so cancel that particular operation. So this is how we control such unfrozen situations. Yeah, I mean this is overall architecture. Like we have only 1-2 minutes. So I recently written one blog about MCP. So let's go through the block, how it will go. Yeah. So as I said, like safe SQL, it is only read-only mode. So by default, it's my server blocks all these operations like insert, update, delete, drop, alter, truncate. Like as a internal use, like I'm keeping a setting allow arbitrary SQL. Like by default it's false. Like for testing point of view, I'm keeping a true. So if I'm asked like coming to use case, we can do some schema discovery and performance diagnostics. And also like my server is not limited to either any one local server or one remote server. So we can connect n number of servers at a time. Like we have that capability in my MCP server. So we have database environments. Like in environment file, we can add n number of servers. So like as I say, like we always use this MCP is only replica server. Like it is good. Why? Because if you allowing to do this in my primary, then there might some over connections and utilization. So I always keep to use this in my replica node. Yeah, the use cases are like faster debugging and like natural language analytics, multi-environment support, and SQL review before execution. So it's in under maintenance. So it is not limited to Postgres. Like I am now working for MongoDB for Target and MySQL. So yeah, thank you. This is all about my MCP.
Thanks a lot, Philip. And I think it's a very new thing, and I'll suggest everyone to give it a try as well. So thanks for your blog.
Yeah, thank you.
Next talk we have from Madhav. He's the CTO for OS3. Over to you.
Display. Hello, am I audible, right? Okay, thanks PG Mumbai for inviting me for this talk. So I'm the CTO and the director for the organization called OS3 Infotech. OS3 Infotech is mainly into the solutions on the infrastructure and platform, the open source. OS3 stands for Open Source Software and Solution, 3 times S. EvoMind is a sister concern of OS3 Infotech, which is a new spin-up, mostly working into the solutions around the AI. And what we are going to see is a beta product by the EvoMind and OS3 combined together. So OS3 is basically partnered with the all major infrastructure platform vendors like SUSE, Red Hat, Canonical. We also have the Center of Excellence Lab and Innovation Lab with the Intel, where we do a lot of R&D around the benchmarking and the new innovation around the processor-based AI. So CPU-based AI, not the GPU-based. So this product is basically into the beta phase.
what we are going to emphasize today is about the Postgres and PG vector combined together, how it can help about the RAG, the one of the product what we have built for one of the pharma giant in India. So this is in beta phase currently, but we will see how the Postgres and PG vector combined together helping this product to build. So we'll try to stick on the technology part. So customers requirement is we want the entire rack system in our data center. There will be no traffic going out. So the complete AI and database and vector database, everything should be inside. So okay, and they want to maintain the compliance and security and everything. So we built a LexiGuard, that's the product name. So the customer want the completely innovative RAG, but only running on the CPU. Why? Because they don't want to spend on the GPU, and they want the system to be lean and fast. We selected Postgres and PG vector obviously for the reason that their databases, the total number of documents when we convert it into the vector should not be actually going beyond the 50 million indexes. So that is something which is true for them. This combination is again because they want to go ahead with the only open source ecosystem. So we said okay, this still works, and since we have the unified access to the single architecture within the Postgres only, so that helps us to design the system and making it more tunable and fast. We work with Intel as well with their 6th gen servers for making it more faster on the CPU. So what exactly this is, I'm not sure this is visible. Okay, I'll make it larger. So basically from the left side, user uploads the data to the system, the LexiGuard. The top layer is about the ingestion flow, where the document goes and it vectorized based on the 800 tokens. 800 is the sweet spot for making the chunking basically. It goes to the Postgres by using some AI mechanism. Now here we see the Open AI and Mistral and Olama. We use the Llama CPP for that because it works very well on the Intel processor for the processor. So we want to avoid the GPU, that's why we use the Llama CPP. The top right, the Brain AI. We vectorize that documents, and then once it's vectorized, the second thing happens as the query, the middle part. In the query, normally it goes in the backend, that's the fast API, and goes inside the Postgres and PG vector with the top case similarity. Basically, it's more suitable kind of answer coming out, and LLM inference that and gives back to the customer. So this is the top level architecture. I will show you a kind of a proof of concept where okay, so here is the screen of the LexiGuard. This is a recorded demo of a LexiGuard, the document track. So similar to what the ChatGPT and Perplexity interface, customer want that kind of interface only. They want the citation, they want the feedback given to the rack so that rack can understand, learn from the feedbacks, thumbs up, thumbs down, and that kind of thing. Even they want to have the citation from which document actually you are retrieving the data. So if you see at the bottom, we have the thumbs up, thumbs down. It's not only for the basic thing, but it's for the learning from the feedback. Again, the relevant subsequent question can be automatically generated by the AI. I'll just fast forward. So that's how the normally what we see in the ChatGPT and the RAG system. Okay, last demo. So here is the proof of concept, how the PG vector and Postgres combinedly working together in the background. So we have created a Python script which is running for this. Okay, this is in the 4 stages. So first stage, what we see here is the first stage. It's initializing the validation of the document. So that's the first stage. Second stage is executing the ingestion pipeline. So chunk the data or chop the data, send it into the Postgres through the PG vector. Okay, once the ingestion pipeline done, third stage will occur. The third stage is inspecting the vector storage. So here is the stage, inspecting the vector storage, the Postgres schema, and the final stage is getting the answer, the executions. Okay, and the final answer will arrive. The question was what is PG vector? Here we can see the question is what is the PG vector, and the answer will arrive based on the document already fed to the rack system. Okay, so here we can see at the end that the RAG answer generated, the PG vector is the open source extension for the Postgres and all, and cited sources and all that stuff. So here is a small talk about how we can use the Postgres and PG vector for the RAG system. Is there the only answer for the RAG? Should we only use this? Can we just eliminate the other vector databases? No, possibly there are certain other use cases where you can use the other kind of open source databases like Milvus or some other. When can we use the Postgres and PG vector combined together, where we have a RAG kind of system? One. Second, we want to go ahead with the not more than 50 million indexes. So those are the couple of, and obviously if you want to run it on CPU, no external access, you want to run within the infrastructure. So those are certain best use case scenario where we can see the Postgres and PG vector combined together you can use for the AI RAG. That's all from my side.
Thanks a lot, Martha. So we are almost there. Just few. So the next talk is by Edu Pyramids from Madhuri and Swapnali. So
Hello. Hello. हेलो हेलो हाँ ये नहीं चल रहा है ना हेलो am I audible? Yeah, good evening, and I'm Madhuri from Edu Pyramids. Okay, so I have a small video before I speak. Okay, let me play again, sorry. Thank you. Okay, so we are from Edu Pyramids Educational Services, Sign IIT Bombay. So I'll just take 5 minutes of yours to speak about our project, and then also the video which we have seen is about Postgre. Earlier we had RDBMS Postgre series, but now we are switching to new series Postgre with 18.1 version with the help of the team. So, but that before that I just want to tell few things about our objective and things like that. So, what is the spoken tutorials are brought to you by Edu Pyramids. The main objective is IT literacy using FOSS, free and open source software. So, we create spoken tutorials for effective learning, and then which are accessible, and we also offer skill based learning or skill based training which is for improvement of employability. All the videos which we create are self paced and for self learning. So, here for self learning, how do we do self learning? We do self learning by learning by doing, like practicing one by one. We have a software and the video side by side. So, a glimpse of what side by side is, there is an image for that. So, this is side by side. So, here we are showing a software and a video on, so the video here is for Scilab, and then the practice is also for Scilab. So, we have a side by side practice. We have the video playing on one side. We encourage video playing only half of your screen. We do not want full screen playing. We always encourage half playing, and the other half of your screen should have software. So, we will be learning. We'll listen to the video and practice side by side. And then, so we make the content, also the content what we all create is available in multiple languages, and this will actually it will help us in learning by doing, improvements in the way concepts are understood, and this also promotes active learning. So, whenever we are practicing along with listening, it will always go for active learning, and it will improve our knowledge. Also, it also helps in bridging the digital divide, like everybody will be on the same front, like we do not have ups and downs. Whoever is there in the class, or whoever is a set of people who are learning, all of them will be on the same platform, all of them learning on their own self-paced and self-learning. So, I have the next slide. This is the spoken tutorial page visits we have. This is in the last week we had taken from 23rd January to 6th of February, that is yesterday, last 14 days. This is how we have our page visits, unique visits, and first time visits, returning visits on our page. The graph shows there is a tabular column and graph which depict the same. Okay, whatever you saw in the video just now was a glimpse of this particular thing, statistics of RDBMS Postgres work. series which we had in 2018, and it's going on till now. So we have 70 plus spoken tutorials in our EduPyramids, and then we also have a award, that is IEEE Standard Award, and other awards too in 2020, 15, and then from 2015 onwards. So various awards, MOOCs award, nomination HT award, and reimagining award for our team. So we already have trained over 1 crore students, and then about 70 courses. Now we are on to the Postgres series, new Postgres series, that is called Postgres database series, which is coming very soon on the ST page. We already started creating tutorials for that. I just want to show a glimpse of it on our ST page. So this is the main ST page we have, that is spoken to the main page which we have, where we have all the spoken tutorials. The list of courses is huge, and also languages are also there, various languages. So many of the tutorials are translated into various languages. So the list of languages is available here. And now I want to share about the new series which we are creating, PostgreSQL. In we are just starting off the new series. We only have 6 as of now, and then we'll be doing more in the series with 18.1 version. So, and the support is from the team here. So I'm very thankful for the team to support us to create this new set of tutorials. I just want to play one tutorial for a glimpse.
To record this tutorial, learners should be familiar.
So these are short tutorials up to 4 to 5 minutes. Is it audible? Audio thoda sa.
Status, space, PostgreSQL, and press enter. If prompted, type the admin password to authenticate. The PostgreSQL service status is now displayed. Notice that the service is active. Press Q to exit from the status. Type the following command to switch to the Postgres user and press enter. Notice that we are logged in as Postgres user. To access PSQL prompt, type PSQL and press enter.
Yeah, this is short glimpse of the video. So the video is short, 5 minutes. So what we do generally is, it is a self-practice video. So we will put up our earphones generally and then practice side by side. So Swapnali wants to say a few things. Thank you.
Good evening, everyone. So my name is Sapnali Kadam. I'm actually working for the EduPyramids training team. So already you all are expert in the postgraduate. So here we are actually going to discuss about, we are going to teach you about the amazing resource which will help students to learn Postgres and even the other open source software tools. So I'll take you quickly to our individual learning. So we actually coordinate with the colleges where we implement this training, not only with the institution but also with the Directorate Higher Education and the technical educations. But we have even launched an individual learning workshop, a platform where not only students, even working professionals or housewife, anyone can register individually for any of these courses, that is open source software tools, including the Postgres. So in our software training, we have an option called individual learning workshop. So any one of you wish to learn these courses, they can directly go on our website and registered. And directly once you registered, you will be receiving the course content in your login itself. So once you registered, the course content can be practiced online and offline in the both method. And the second part is we have this courses available in 22 Indian languages. So you can learn in Marathi, Hindi, any Tamil, any languages. So other thing is we only want. No. This is
So these are the list of the trainings which are ongoing right now. So we actually want you to go through our website, just go through the tutorials which we are offering. And secondly, even if anyone is from academics or any organization, they can even reach out to us to explore this training. Even we work for the corporate training also. Even you can reach out to the students who are looking for such courses. And we are offering at a very nominal cost, that is 299 plus GST for all the courses. Secondly, so this is our platform. So these are the ongoing courses, individual learning, where you can register. Last page. Can I have it? So through this Edu Pyramids, we have trained more than 1 crore students till date, and it's increasing day by day, since we are already tied up with the higher educations also. So we want your support to also reach out to as many students we can. Yes. So hope this is clear. So thank you for your time, and thank you PG Mumbai for giving us this opportunity to thank you.
Thanks a lot, ma'am. And I think as part of community enablement is very key important. We are almost there. We are at the closing note. Ashutosh has one announcement to make. I'll just hand over to him. Then Somnath will take the final closing ceremony.
Does everybody know what PGConf Dev is? It's a annual conference, annual developer conference that happens usually in Canada, and where most of the developers, community contributors come to come and talk about the development that is happening in PostgreSQL. The talk that I gave about SQL PGQ implementation, there will be a meeting, developer meeting, that will be hosted in the same conference, where we will talk about what to do next with the graph databases in PostgreSQL. If anybody of you would like to influence the roadmap of what happens in PostgreSQL around graph databases, please, I request you to attend that meeting and also attend PGConf Dev around that time. Thanks.
We're good? Okay. Thank you, gentlemen. Thank you, ladies. Thanks, everyone, for coming over, spending a Saturday, a full day, and this is overwhelming. I mean, when we started PG Bombay, as Trushar mentioned in the morning, we were honestly not sure. I'll be very candid on one front. Postgres is something developers have been adopting. So Postgres conferences have been happening in Pune, in Bangalore, Hyderabad. So that's been the developers hub. And Bombay being the industry hub, the technology buyers are here. But they have been buying technology mostly on the proprietary OEM side. And Postgres was a tough question. I mean, I recall in my previous job when I used to go to companies and they used to, does your database do active-active? Does it have sharding? Do you have transparent data encryption? I'm talking 4 years back. That was the conversation we used to have. Today, I have an audience where only like 20% of the people who have not worked on Postgres, rest have all done it. So that gives us a lot of motivation, and that's why we wanted to have it in February. We did the last one in November, and we wanted to do immediately in February. These are some of the numbers that we just saw, okay? We reached about 30,000 odd people on LinkedIn. We don't have any paid media, nothing. It's just simply social. That is what we spend on. I mean, we don't even spend, and whatever organically grows. We had 75 followers when we had our November meet, and now we have about 352. So if I reach out, we are reaching out to 350, but that's a small number again. The most important part is, again, I really thank you, gentlemen. I really thank you, gentlemen, for this. What is happening right now in Bombay, in Postgres, some people in FOSSI, they are trying to, FOSSI Edu Pyramids, they're trying to enable thousands of students in remote parts of the country to work and start learning Postgres. That's one journey. I have seen advertisements coming from public sector banks hiring manager Postgres databases. I'm talking 2 weeks back, a very large public sector bank. Private sector banks, they have started adopting left, right, center on small databases, and some of them have even gone mainstream. And we have people in this audience who have done transformation programs for large public sector banks, large government institutions in Postgres. I don't want to name them and call it out, but then they know it what I'm talking about. So the change maker is, gentlemen, you. Adopting, enabling, solutioning, architecting, delivering all on Postgres. It's someone from you will actually do the next transformation program out here in Postgres. That's how things will improve. So a very big thank you to Fujitsu, who came in at the last minute. Mark was like, you know what, we'll do it. Just guys, just go ahead and get it done. I said, okay, Mark, we are good. So they became our first sponsors, and immediately we also had a great support from OS3, Ashnik. FOSSI was the backbone. Edu Pyramids was the backbone. Professor Kannan, okay, Professor Prabhu Ramachandran, they were the backbone. They helped us, just do it in IIT, we'll get it done. We'll sort out things for you. And yesterday when I was doing the recce of the event location and everything, they were through me with all throughout the day, taking me to different places, getting the paperwork done, getting the gate passes done. And some of you had those gate passes where you just give it to them, or you just told, I'm this, okay, head to this. They just made it possible. So what next? I don't want to take much time because at the fag end of the day, okay, when do you want the next PG Bombay to happen? Just audience, anyone? No, just throw a number. I mean, throw a date. We can try different formats, please. Sorry? 1st April. Okay. Anyone else? Huh? 1st April. Any? Okay. थोड़ा bias हो रहा है. और आगे कुछ? Any other number? Any other date? Okay. So what I'll do is, we had planned for a larger event, something similar, but even on a larger piece, which will be 2 parallel tracks. So it's like 1 track here happening, 1 track happening in another hall, something like this. You have 2 talks running all throughout the day, different talks. You choose which one do I want to attend, because this is a mature audience. I have to really say that I can't have novice programs, novice talks. Thanks Ashutosh, thanks Jeevan Chalke, thanks every speaker, Manan, Drishti, every one of you for coming over and getting this done. But the next one will be 2 parallel tracks, and more than 15 plus speakers are expected. Now, April and June, I'll keep it in mind, we'll do some short digital online meetups, small meetups, like 2 hours or something like that. We can definitely get it done. That should not be a problem. We'll get that done. I just want to thank everybody who made it possible. I would just request all the speakers to quickly come to the stage, please. Bapat Sahab, Shalke Sahab, please, Trishti. I think we are missing somebody. Yeah, I think we are missing somebody. हाँ, वही मैं बोल रहा हूँ. कहाँ गया? Can we have a quick photograph, please? We can. There's one gentleman from Ashnik and OS3 as well. And yeah, please. And Madhuri ma'am, can you please join us? I forgot your name, my bad. You guys should be at the center. मैं तो आखिर वाला हाथ बंदा हूँ. No, that's okay. They are more important. Madhuri ma'am, you be on the stage. The volunteers, please. Those who literally worked behind the scenes to make it possible. नहीं तुषार, अरे क्या बात कर रहे हो? आ जाओ. Yes, yes, Madhurika ma'am as well. Yes, I'll just call them. Amit, guys. I think you should be there. I think both of you should be there. Please, Deepak, quickly. Let's because I want to just finish it. Let's. हाँ सुमन sir. Yes. अरे कहाँ चले गए थे? Hero. Please. आ जाओ sir. Thank you, everyone. Just give me 2 minutes. So what we planned is with a very selfish motive. Okay, there are a lot of global team members who generally visit their home in December. A lot of them. Okay, people from different parts of the world, different companies, AWS, Azure, Google, even some of the very big contributors. So today, as we speak, PG Bombay, there's PG Bangalore also happening. So one of the big contributors, Amit Kapila, could not travel because he's the organizer there. So we'll have the next big event in December. That's a promise. 2 parallel tracks, 15 plus speakers, maybe more, and I'm sure it's going to be a bigger event. Again, gentlemen, ladies, the final change maker is you. The final change maker is you, who will change the landscape. All the digital sovereignty that we need, however we need. This is just a path. Thank you, everyone. Thank you. Thank you so much. Yes, if you can get everyone on the stage, please. Every one of you. मैं सीरीज में बैठ रहा हूँ भाई, पीछे सब सारे बैठ जाओ. We'll have to find a way out. I think the tallest guys go at the back. हरी तो आप पीछे. ये भी कर सकते हैं. Achha, actually, okay, Jeevan has a good idea that we all gather in these parallel lines and they can take a photograph from here. Make sense? Yeah, I think. Sorry for the inconvenience. I think just line up in this part so that the yeah. यहाँ से. So photograph can be taken from here. Gentlemen, quickly. Oh, by the way, can I just come over. Just 1 minute. But you are the youngest developer in this conference, and I'm sure you're into PCM, right? You're into engineering, right? I'm sure you'll have a great one.